Thanks, Alex. And if you didn't hear, we are recording. Also, we on the tables, you should have access to Q&A. Here, I guess I don't. I'll just hold this one.
Having fun.
All right, can everyone hear me? Great. So yeah, today happy to announce we have a slight change actually on the first bullet. John Gibb from DKS, he is going to give a presentation on our sensitivity analysis for our model. So I'm going to talk real quickly about a couple of use cases as to kind of why the sensitivity analysis is important. We glossed over quickly managed lanes yesterday in terms of model application. There's a variety of projects going on in the region that are looking at different types of managed lanes as an option. How people travel, what their willingness to pay, their evaluation of time. These are all factors that are really important and applicable to if someone's willing or not willing to use a managed lane and when. We also shared in a few of the blueprint slides and a few other presentations, we have our SB 743 screening maps. This is household VMT. You can also see from our current plan a trend line that forecasts VMT in the region. These are performance metrics that evaluate our plan. They're also tied with state legislation, and they have a lot of policy implication, whether it be funding or if projects are developed or not. So understanding, are these reasonable? Is the model accurately forecasting what we're predicting? This is really the core of what we're using the sensitivity testing to evaluate. Here is some quick graphics from our pathways we mentioned as part of this blueprint or MTPSCS. We analyzed kind of 3 different scenarios: an outward expansion, a kind of balanced, and an infill development. Some kind of set the benchmarks to our policy and board as what's the possibilities of having these different types of land use and transportation interactions, and what are some of the performance metrics and indicators that we can find from this analysis. This was a bit more of a sketch. Sketch is the wrong word. We use the model, but it was to kind of set the framework as part of our blueprint to get to ultimately a draft preferred scenario. But we were asked a lot of questions. What if we substantially increase transit frequency, 15-minute headways across the region? What if we significantly expand our lane miles in the entire region? How would that impact a lot of different performance metrics tied to the triple bottom line of equity, the environment, and the economy? And the question to that is really, okay, we can do this forecasting. Our model can predict some different numbers, but how sensitive to these different inputs is it? And so we wanted to get to, is it sensitive to land use, demographic data, kind of really be able to answer our reasonableness and comfortableness with the model. So we put out a call for projects, which, as I mentioned earlier, DKS and John Gibb provided a sensitivity analysis to our latest model. And so with that, we wanted to share a bit of the results and findings from that. So John, I think if you can, you're welcome to come up now. You want a computer?
Okay, I'll be using this. And let's see. Yes, thank you, Kyle, and good morning. As Kyle mentioned, I mainly did the sensitivity analysis that we concluded about a year ago for SACOG, in which we used a draft version of the updated SACSIM, and it would take probably a month to prepare an interesting presentation and probably take an hour, but this will be just some highlights from it, and we're probably going to miss a lot of everyone's burning concerns about one topic or another, I'm afraid. But anyway, the purpose of the sensitivity analysis is, or the The idea of it is, is SACSIM reasonably sensitive to key factors that go in? Where SACSIM inputs demographics, land use and built environment factors, and the transportation network, and out come person trips and tours, um, and they come out by mode as vehicle trips, transit trips, and so on, and ultimately as traffic and VMT. And we need to do this, one, just to establish the model's suitability for comparing future regional planning scenarios. And it's required by the regulatory agencies. And the model has changed since SACSIM 19 that we know and love. The draft that we're working with is updated to a 2020 base year, pre-pandemic conditions. They've significantly added TAZs to the network and TAZ resolution, the same area, but more resolution. RSG re-estimated the model choice parameters from a 2018 household survey. Those were used as calibration targets back for SACSIM 19, but they didn't get into the estimations at that time. This model now has a work at home model. It was adapted from pre-pandemic conditions, but it has a little knob in there that we can represent increased work at home. And they've revamped the network free flow speeds that start off the model. And of course, DAYSIM's just been evolving. Okay. Oops, I went twice. There are 3 types of tests going on in here. Some of them are cross-sectional tests where you got just the base model as it is, and we classify the people where they live and how much trips in VMT they make, and get relations between them. Another is a bunch of experimental model scenarios, and then there's another group of tests we did, which was just random variation alone. And most of these tests are similar to what SACOG did for SACSIM 19 a few years ago. Oops, did I go twice or once? Okay, in the cross-sectional tests, we cut it down to 3 dependent variables, VMT per person, transit trips per person, walk trips per person. With independent variables, yeah, there's a whole bunch of independent variables. Most of these are just D's measures, street pattern, residential density, and all, and give kind of the purpose of these measures on the left and the actual variables as measured in the model, as provided in the model on the right there. These are mostly things that are difficult to define and create different scenarios for anyway. So the cross-sectional test makes more sense, and CARB accepts them and all that. This is just a reduction of some of the data here. This is one of them, auto accessibility as in jobs within 30 minutes of driving. If there's more, then people tend to need to drive or drive less. And this is controlling for demographics, in this case, income. A similar thing happens with transit accessibility. As with more things they can go to by transit, that tends to go with the less VMT. The model accounts for demographics. We got their 8 or some odd person types, and they show reasonable variation. The VMT per person shows reasonable variation among these person types, or their workers, non-workers, retired, and so on. Controlling for income as the other variable. And street pattern, that's where it's based on the number of intersections, one of those notorious variables we have to put into the parcel file. It definitely shows a difference in the model there, in the model results there. But the real part of those are just selected, bivariate classifications. The real analysis was a multivariate regression with, and then some calculated elasticities. It's very similar to what was done in SACSIM 19. got like around 5 or 6 demographic variables altogether, plus one test variable, or plus all the test variables. But I'm not going to walk through all that. Just see the report. And there are comparisons to published values in various research literature to show that we're, if not overlapping the ranges, at least near them or in the right direction. But that's all in the report. Now, what happened there? The basic conclusion of it is that SACSIM is reasonably sensitive to local and regional D factors when you control for demographics. Experimental testing is another major part of this. This only required 63 test scenarios of SACSIM, changing one input factor per scenario. And many of these factors are not intended to be realistic or probable or recommended or anything like that. Dependent variables, we got a few more of them there. Now we're looking at total person trips, vehicle trips, VMT. There's another measure of congestion, congested VMT in there. And transit and walk and bike person trips is what we summarized in there. For a variety of independent variables, some of them in blue are the ones are the same as in the SACSIM 19 sensitivity in the documentation, and some in red are new. A little more on the transit side, and a few more looks at, there's a new telework model, and there's a highway free flow speeds test there. And every one of these is a table, is at least one table. Every like group of things that are varied is at least one table in the report. And this is just attempting to highlight them. And somehow the presentation is mangling them a little bit here from what I was looking at last night. But yeah, a bunch of text is chopped off. But anyway, there's a group of transit network scenarios. The ones on the extremes are where we double all the headways or have all the headways of transit in the entire region. And then there's some others where we'll remove, like around, I think it is like around 10 transit lines, or remove just one light rail express segment. And then in the middle is the base, and then going off to the right would be adding 3 bus lines, and then adding, I think, 93 bus lines. And the dark line is what the transit person trips do. Generally, as you expect, more revenue hours is the x-axis, and more transit person trips is the y. It goes in the right direction, and it takes away, it substitutes for other modes, like you'd expect, between auto person trips in yellow and walk and bike trips in the dark green. And then the light green should be total person trips. So we're actually seeing a little bit more total person travel due to this added transit accessibility, but mostly a substitution among modes. The blip in the transit, why it goes down there with the remove an LRT segment, just shows that the model is way more sensitive to an amount of revenue hours of light rail than it is to the same revenue hours in bus. And that's reasonable because it's such a large and intense service. What happened? There we go. Other tests like this, if we vary the parking price downtown, okay? More parking price, that's the x-axis is the median parking price. Well, more parking, less auto person trips. It substitutes somewhat from, okay, much of the substitution is transit, a little bit of walk substitution, but there is a total difference in person travel as well, coming and going from downtown Sacramento.
Excuse me,
Okay.
John.
Yeah.
I have slides that show all, I think it has all of your the text up there. Would you like me to share that for you? Yeah.
Oh, you have the version that shows the text?
Yes, I think I do.
That would be good.
Okay,
Yeah,
let's do
somehow this
that.
got-
Sorry about that. Um,
trying to
Let
make
me
my
see what I've
text
got
big
for
enough.
you.
But,
Yeah.
I would've had that all figured out last night.
Yeah. Let's try this.
That's looking nicer.
Does that look better? Okay.
Yeah.
Okay. If you, so your clicker's not going to work anymore, but if you'll just say next slide. Yeah.
Yeah. I thought for a second I was going to get the inevitable interruption at the Ig Nobel Awards. I'm bored. Please stop. I'm bored. Please stop. Recommend to see that. Some great unusual science.
Yeah. Okay. Try your
I
clicker.
like
There
it
you go.
there.
Does that look better? Okay.
Much better.
Okay,
Yes.
great.
Teleworking. That's a new feature in the model. And instead of placing, now the knob that you turn in this is an alternative specific constant in a choice model. Okay, so if you add 0.01 to the constant, then you're going to kind of promote things about 1%. But we tested much larger changes between making it less than the base year or making it more than the base year. And we kind of see what we expect here. The blue is persons working at home. Okay, yeah, a lot more of them. And that takes, and in this model, that takes away from auto person trips and from transit person trips as well, and total person trips even. But this is again based on the survey data mainly from 2018. New research may change these things as it eventually trickles into SACSIM, but that's the present response of SACSIM. Okay. There's always interest in, if we widen roads and expand the highway system, how much VMT grows. So we got a bunch of scenarios here. And sorry, it's just a boring table. But we did some rather arbitrary scenarios, not like the priority list or anything like that, but some really arbitrary scenarios here that may or may not have a chance of getting widened in our lifetimes. And I've classified them by the type of road, arterial or freeway, and is it congested a little bit or a lot or not at all. Like Sunrise and Watt are fairly congested arterials. El Camino Avenue, no one's going to widen that. It's uncongested, sleepy little arterial. Compared to, say, Route 51, the capital city freeway. And that first column there, you see the difference in the elasticity of VMT to lane miles. It isn't one number around 0.7 to 1, like certain regulatory agencies would insist upon. It varies quite a bit and reasonably. When it's severely congested, like Route 51, you get a rather serious response of new VMT if you add a lane each way to that. And then we got some other roads as well. And then down at the bottom are some global tests where we just added some capacity to all the arterials or all the freeways. Now, when we break down elasticity of VMT to lane miles into parts, speed to capacity, well, if it's congested, you're on the steep side of the delay curve. So you expect a lot of speed change to capacity change. And that's what you see on the congested scenarios, especially Route 51, Sunrise, and Watt a bit. But then the remaining component of VMT to speed, by the way, the last two columns multiply to get the first column. Those are all those are way more stable in order of magnitude. There's another oddity here. The Broadway Franklin Road Diet project in Midtown Oak Park area has a negative elasticity. Now, how can that be? You're taking away lanes and you're gaining VMT? No, you can't do that. But the model responded by, but with the context. You know, the model knows the context, not just a gross number. And the context here is there are alternate routes to those which happen to be a lot faster, as in freeways that take people around those, and the model responds expectably to that. So basically, induced traffic from SACSIM means adding capacity to congested roads induces more travel demand, but to uncongested roads induces little. And removing capacity can increase BMT. Now we finally get to the third group of these things here, random variation. Now, the report just gives tables, okay? And taken straight out of this table is just a couple columns out of there. One is just the average of trip ends in a rad, in each of 3 rads by different modes against the standard deviation of those same numbers of trip ends. Now, looking at all the reports you ever see in published literature, as well as model development reports and the last SACSIM sensitivity, you just see these numbers and think, okay, well, that's what they are. It's like the atomic mass of iron. It's just what it is, okay? Well, there's a kind of regularity to it that I thought worth looking more into. Is that when log scale, you see a regularity to it. It's about it's like the standard deviation is somewhere in the order of magnitude of the square root of the average of trip ends, or whatever the quantity is. And this holds true with other quantities as well. So now let's all get bored here and try to remember our probability theory from school here. Variance is the square of standard deviation. We'll be referring to variance a bit. There's some conveniences to that. If you have you can model things in here with a binomial distribution, as in if you have n independent trials like coin flips or dice rolls with p as the probability of success. Okay, the average count of successes is n times p. That would be, and then the variance of them. Okay, that's also related. Particular tours by an ABM tend to have low probability. You got a huge choice set of all sorts of things people can do. And so 1 minus p just approaches 1. So you approach a Poisson distribution. The variance is the same as the count of successes. Now, variance is squared units, decisions. The average count is just whole units. Some people can't get over that as an incompatibility of units, but independent decisions are unitless. And it's the natural variance you get from how many times you throw a dice and it comes up ones, or flip a coin, it gets heads, or take or something closer to a model is like you take someone has made a die with 1,000 faces and made 1,000,000 of these things. Okay, what's the average you're going to get out of that, of a certain number? Well, you get 1,000, give or take something, and that's predictable by probability theory. You got a huge choice set, and each possibility has a small probability in its own right, but we have a count of how many occurred in one model run, and the number that occur in another model run is somewhere around there. It's in the predictable by probability theory range. But part of the usual theory that we'd refer to assumes independence. That a person making one trip is independent of making another trip, or something like that. Now, the very nature of activity-based models is that every person day's scheduled formation, well, there's independence from one person to another, almost. But the way these ABMs work is we're trying to form coherent schedules of people in a day. They have to be feasible. And so one tour that a person makes, tours are almost independent decisions, but one tour that a person makes affects another tour. People are like 4 or 5 tours in a day is disproportionately unlikely compared to the average number they make, compared to, say, a Poisson distribution. But then there are some other interferences of people's choices to each other. Feedback of congestion. So we have feedback loops in the models. So what people chose in one loop affects the travel times and thus the choices in the next loop, and we try to converge that to an equilibrium. And there's another effect that we're trying to balance workers to jobs at every job location with a shadow price iteration. So it's competitive equilibrium we're trying to solve for, and that tends to induce some negative correlation between tours. And then, of course, when you're analyzing trips or trip ends, well, they depend on tours. So like at least 2 trips are formed from every tour, and at least 4 trip ends are formed from every tour. And there's some laws of probability theory that go when you scale things. Okay. But what this is pointing to is let's look at tours because they're closer to independent of each other. They're kind of the basis of the details. And there again, I've put the number of tours by every RAD in the region, classified by the work tour purpose, a non-work, and then just all of them in the triangles at the home RAD. Now, what's happening here is they're not clustering around one exactly the way you'd expect from a Poisson distribution of independence. They tend to be a little lower, but I was just recounting that they go through competitive equilibrium, which tends to bring it down. But you still see individual RADs, some higher, some lower. And if we're worried about that, meaning, oh, well, these RADs are special. They're less random than those ones. But actually, the variance is a random variable itself, and it follows a distribution as well. And I have some material on not in the sensitivity report, but I do have a TRB gig that gets into this, which will get into this here. Another one, where'd it go? If we do the same thing at the attraction side of tours, the destination side, these mostly cluster around the 1 to 2 range. The work-based tour destinations, or the yellow diamonds, they're a bit noisier than the non-work tour destinations. I also got in there the work-based tours, the sub-tours that people make during the day to get lunch or errands or whatever. Those tend to be a little noisier. Here, let's quantify the average of these relative noise levels. Work tours by home location tend to be lesser than, they tend to be less than the random noise prediction. Well, people tend to not make 2 or 3 work tours in a day. They're really disproportionately unlikely to make extras. Workers tend to be very regular about going to work, at least back in 2018. And so you get numbers less than 1. And then non-work tours similarly, just because the falling off of the tails of the distribution. Work tours at the work location, they're showing up as noisier. But then let's go from work tours just to the number of workers. We have a work location choice model, and that's quite a bit noisy by TAZ and RAD. But when you get down to the region, it should be 0 because we're allocating a fixed number of workers. So that 0 is there, there's total number of workers in the region. So as you get bigger aggregation, you get more of the falling off to 0 there. And then work-dependent tours, work-based tours, they're a little noisier as well, probably because the work location is noisy. And why is that? Let's see, is that in the next one? Well, yeah, it's likely because the worker job shadow prices are not solved exactly. But otherwise, we're seeing things that are generally in accord with probability theory. It could be investigated deeper, but we're generally seeing that. But it also tells us when we're baffled about a difference between model scenarios, and we see the difference in something like person trips or vehicle trips or something being a small difference. How can we figure out if that's due to noise or a real difference? That's often a that's we're often getting questions like that. In fact, we're kind of talking about one lately about the problem of somebody at another agency um, did something to the added transit service, and they're trying to figure out if the why the VMT went up or something like that. But the difference was so small as likely due to noise. Well, how do you? I don't have the calculated answer to them, unfortunately, but there's a way. But the probability theory indicates a way to estimate the order of magnitude of how much noise to expect in any quantity. And if it's relatively independent quantities like tours, you're expecting something like its variance to be close to the whole number in the order of magnitude. Or you could say its standard deviation somewhere around the square root of the number. Now, when you get into derived quantities like trips or trip ends, it might be 2 times or 4 times that, depending on the relative amount of dependence. We've scratched the surface of sensitivity of SACSIM, but we're showing a lot of things generally in the right amount and direction. I could only pick and choose a few little things out of the report, and it's available anyway. Thank you for bearing with this.
Thank you, John. Thank you very much. Give him a quick round of applause. If you would, if you may want to stay up there, don't leave quite yet. You still have to sit in the hot seat for a minute. If folks have questions, I wrote down shadow prices, but we can follow up with that later.
Okay.
Any questions so far? Okay, we got 2 in the back. And then if you will just, so I'm going to give a reminder about how to use the mics. So there's a mic on your table. Just leave it on the table and press the button until it turns green just once, and you can speak into it. So we'll go you and then you. I can't see your name tags right now.
Hey, John, quick question on the aggregate nature of the test. What you showed so far seemed to be done at kind of the model wide scale and summary. Did you do any testing of more localized, like individual TAZs? Because so much of the application of SACSIM does get applied at the local level, it's simple interchange or a specific plan. So can you say anything about the testing at that localized level?
The truth is about 90 some odd % of all the tests in this entire report are regional totals. That's what we ended up with. There are a handful that focus on a RAD or a group of RADs.
Thank you. All right, next question.
My question is a more general question. I want to know, like, based on the sensitive analysis, what are like the most sensitive, like dependent variable that you see for like the SACSIM, and for that for those variables, how likely are we going to see the outliers when we like collect the responding data?
So what are the most sensitive variables? Okay, and where are the outliers?
Okay, is this concerning the random variation or the one at a time scenario variation?
The random variation.
Oh. Okay. Oh.
We stopped you. You want to go back? That's fine. I can do that for you. 1 second.
Try to pull back one of those scatter charts there.
Which one?
Yeah, way late.
Okay.
One of the last. Yeah, let's just say the last scatter chart. Yeah, we see some outliers up there. The biggest outliers are all work tours to job locations. Okay, and we have a highly suspected reason for that. That being the incompleteness of converging the worker job shadow prices.
John, can I ask a follow-up question, which is if our attendee was to look at the report, would that help kind of answer some of those
Some.
questions? Some, okay,
Yeah, I can't say we did a detailed outlier analysis or anything like that.
got it. Thank you.
Yeah, in fact, much of this is actually beyond the report, but I took some stuff, I took that very model and figured, okay, you got this kind of orderly relationship, but how can we really understand it? And they wouldn't let me actually put stuff like this into the report as I was studying at the time, because there's practically no published literature on analyzing activity-based model of variation this way. Even though there are people who understand this, I've talked to them, encountered them at conferences and the like, but I've seen an awful lot of literature that makes no attempt to relate it to probability theory. Okay.
Got it. Well, thank you for the question. Maybe you will be paving the next iteration of this research. We'll see. Any other questions? Online, we'd love to hear from you. All right. If not, thank you again, John. Very wonderful. We'll be looking at your report. Great. And we will move on to our next topic. Let me get out of here real quick. We're going to talk about the project performance assessment tool, PPA. So that's going to be Darren, followed by Chris. So Darren's going to come up here in just a moment. We've got Chris and I were talking earlier. I've got a little bit of a cooking show style where they're going to show you, they're going to do a live demo, but it's like when you put the turkey in and it comes out all baked. So we won't have the lag time for when it runs, but you'll see it all. All right, Darren, you're in there in the Zoom yet? Okay.
And then I am in Zoom. Unable to join the meeting. Let me try this again.
All right. While Darren gets connected, I have a probability issue. So I have two children and they were born on the same day, 3 years apart. And I've asked this question, like, what is the probability of that? So I'm going to think about that, John. Okay. So it's the birthday problem. Great. I took a stats class in college. It was very interesting, but yeah, we'll have to get the table on that a little bit later. All right. So you're connected. Wonderful, Darren. I'm gonna come and help you here for just a second.
Yeah, so it's just like,
No, you're all right.
I'm trying to close Outlook and it's like, I'm trying to get to the stupid window behind the other window, behind the other window. All right. Yeah. And then discontinue. And then, where are we? Oh, it's up here. Yeah. And then, all right, now I can share. I'll just share my screen.
Great. Thanks for your patience.
Share. There we go. Yay tool and hide myself and full screen. This. All right, we're looking okay now. This is tolerable. I don't like that stupid menu bar at the bottom though. You know what? Don't worry about it. So yeah, I'm going to talk about SACOG's project performance assessment tool. SACOG has had some version of this tool kicking around since around 2018. It has evolved quite a bit in the intervening years, and it is now a fairly user-friendly web-based tool that outputs a data-rich PDF report. It's, like I just mentioned, it's a web-based spatial analysis tool. Okay. And what it does is it computes a lot of key metrics about the environment on and around a transportation project. So anything from a proposed transit route to a bike path to widening a highway, anything that's a transportation project that can be represented by a line or even an intersection. And it gets a lot of metrics around land use, like population and job density, looks at travel behavior, like the VMT of residents near the project, the mode split of people who live near the project, looks at transportation infrastructure, such as what's the amount of transit activity around the project, how much of the road network near the project is bikeways. It also looks at congestion and reliability data, like on the project segment, how much traffic congestion, how intense is traffic congestion, how reliable are travel times by driving. And of course, it looks at crash data as well as a course estimate of collision risk on the proposed project segment. These data help us give a needs-based assessment to help us prioritize how we spend transportation project dollars. Critically, this project does not predict what the project will do. It is merely just getting data about the environment around the project. It is not going to give any prediction of how the project will change travel behavior. Little examples of how the project performance assessment tool has been used. It's the regional funding program is probably the best known example, and Chris will talk about that in a few minutes. It's also used for SACOG's community design program, as well as the active transportation program. In particular, there are a lot of cities and counties that use outputs from the PPA tool report to help them to supplement their state active transportation program applications. And then sort of a indirect use of the tool in a different process is it was used in our Green Means Go infill housing grant program, where it helped us prioritize how we allocate dollars to infill housing projects that are in like low VMT areas or areas with high accessibility to services and jobs and transit. So I will go through a partial live demo, cooking show style, of how the tool works. So when you go to the publicly accessible link, you end up on a page. Let me just refresh it so I can really simulate, like, once you go to this link, then the link will be at the end of this slide deck. It loads up a map of the region, and in this home tab, there's this SACOG regional program. You could do community design, but for today's demo, I'll just do the regional program. And you as an end user, you start by drawing a line representing the location of your project. So let's just pretend we're going to do a project along Auburn Boulevard up here, just along this segment. This could be anything. This could be bus only lanes. This could be widening it. This could be bike lanes, anything. I did not mean to click that. And then you give it a project name. So I'm just going to put test, jurisdiction. I'll also put test. And the project type for this one, we're going to just say it's a complete streets project, but you could also choose it as a arterial or transit expansion project. And then you choose performance outcomes. Chris can talk more about the policy context of what these performance outcomes mean, but they all have specific metrics that are associated with each one of these performance outcomes, or I like to also call them like policy goals. You can select all of them or just one of them or however many you want. And then you enter your email, you confirm it, and then here are some manually entered project inputs that we don't readily have data layers for, so we ask the end user to enter it. One is the average daily traffic, or ADT, also the posted speed limit along this segment, and then also the pavement condition index. We are in the process of, over time, we're hoping to add a data layer for the pavement condition index so that users don't have to manually enter it. Similarly for ADT. But for the time being, we're relying on users to provide their own estimates of it. So you enter all these data points, and then you hit run. And I'm not going to do it right now. We're going to show you a completed report. But when you hit run, the tool will give you a confirmation message, and it will just send you about 5 to 10 minutes, depending on what you run. It'll email you a PDF of the output report. So you just hit run, you can close the tab, go on about your day, and then within 10 minutes, you'll get an email with the PDF report. And that report, I'll go through a couple. It's too long for me to go through the whole thing right now, but this is what the cover page looks like. Let me zoom out just a little bit. Let me see here. It's just very basic, shows a map of the project that you just drew. In this case, our project was Broadway Complete Streets, going from, I think, 24th Street out to the top of Franklin Boulevard. And it gives some of the top level data you entered for it. And let's see, I'll go through, like I said, just going to go through a sample of the out metrics it does. But for example, you have the total jobs and dwelling units within a half-mile of the project, just a simple buffer around the project line, how much stuff and how many people are doing things near your project. You also have accessibility. So this is for the average person living, I think it's within, or the average person living right on the project line. How many places can they walk to within 30 minutes? How many places can they bike to, drive to within 15 minutes, or take a 45-minute transit trip? And it also compares the values for the project against what's typical for that community type. So compared to other major arterials in the region, this segment of Broadway has significantly higher accessibility to key services such as K through 12 schools, higher education, libraries, grocery stores. So there's just a lot more stuff near this project than relative to other urban arterials. This one also shows free flow congestion, and even though congestion is becoming having less policy importance in the funding round, it's still, this is from a technical standpoint actually a pretty neat indicator to have, because one of the input data layers is the NPM RDS traffic speed data, and what this tool does is on the fly it conflates that traffic speed data onto the project line you drew. So these are based on observed big data sourced speeds, which is kind of neat. So you can compare free flow speed, which is 85th percentile, to congested, which is the average speed during the slowest 4 hours of the day. And then, so that's a neat data point. You also have travel time reliability, again, based on the NPM RDS data. And then let's see, another neat feature here is transit activity. So how much transit activity is happening. We define transit activity as the number of times per day that a transit vehicle makes a stop within a quarter mile of the project segment. And we also, again, similar to the accessibility, compare it to what's typical for an urban arterial and then what's typical for the region. And we can see that this project has, relative to most urban arterials, has a lot of transit activity on it. That is because it's along the RT51 corridor, which is one of the highest frequency, highest ridership transit routes in the region. So this is just a neat way to get an idea of what's going on in terms of the amount of transit activity. It's also a good proxy for probably how much pedestrian activity may be happening. Then I'm going to just cut down to safety. Let's see. So another big thing we take concern about is safety. And so for the PPA tool, we use TIMS data, and this is we give a simple top line number of how many total injury or fatality collisions. I should add that to the title there. This is not all collisions, it's specifically injury or fatality from the UC Berkeley TIMS system. So from 2014 to 2018, it was 57 total fatalities. And we can use a useful heat map to kind of identify where those collisions happening. And we can see it's really concentrated at intersections, which is not a surprise. And this is very critical for a reviewer to understand, like, well, is the project going to address what's happening at intersections, which can really help with which can really help with understanding if this project going to speak to the root causes of safety problems on this corridor. We also normalize it by VMT, and we can see that even when normalizing by the amount of VMT on this corridor, that this there's a relatively high number of fatal or injury collisions. They're roughly 4 times as many as what's normal for an urban arterial. So there's definitely a safety issue on this corridor. It also shows what share of the collisions are fatal and what share of them are bike ped. You can see out of the many collisions, there aren't actually that many fatalities. Not that there's not a problem, but just no fatalities. And then similarly, a slightly higher than average percent are bike ped. And I will stop there, I'll stop there for the example report, and I'll just finish up my share of the presentation by just going to, let me see if I can blow this up again. Some of the things that are ahead for the PPA tool. Oh, nuts. So near term, meaning this year, early next year, we're hoping to update the data layers. You probably saw a lot of things referring to a 2016 land use or 2014 to 2018 collisions. So we want to update those to be more current. We also are continuously trying to improve tool speed and reliability to reduce crashing or sort of unexpected errors. And then later, longer term improvements, we want to add more equity metrics and sort of enrich the safety data to give us more insight about, like, in addition to total collisions, like what kinds of collisions or what are the primary causal factors behind collisions. So with that, I will leave it to my colleague Chris to walk through some more of the policy context of the funding round and give some more insights on like the why there's value to knowing some of these metrics about projects.
Great. Thanks, Darren. Great job. Very good. Give him a round of applause. Real quick, before we switch, I just want to check and see if there are any questions so far that Darren can answer before we dive into Chris's portion. You're not off the hook yet. All right. Oh, wait. Yes, go ahead. Yep, just press the button, leave it on the table. Yep. Is it green?
I saw like the project community type and region. Is region the whole SACOG region, or is it specific to like Sacramento?
It's the whole SACOG region.
Any other questions? Good question. Kyle has a question.
Yeah, thanks, Darren. It's been fun to see the evolution of the tool. So I think the funding round is a great application. Kind of where you are now with the PPA tool, how do you have you thought of other applications that you'd like to see, say local jurisdiction planners or their consultants use the tool?
So,
Yep.
oh yeah, yes, the folks online. Yeah, I mean, as I mentioned in the slide, there are a number of other applications that at least SACOG has used it for, such as Green Means Go and the Community Design Program. There's a state active transportation plan. I would say one real neat application that I didn't even touch on here that I think a lot of jurisdictions get value out of is actually, apologies, I want to show one more very quick thing, is up here. There's a data layers thing in the tool where you can like turn on lots of just like screening layers to kind of, so this is showing like what's VMT per capita, or you can see a layer of like where are environmental justice areas and what types, or also like you can get a region level collision map kind of showing where all the collisions are. And this is just a lot of these are the data layers. You saw these in the tool report itself, but this is sort of a way where you can kind of do it in addition to saying, okay, I have a project, how good is it? You can start saying, well, let's just look at the whole jurisdiction, see, are there places where there's a need where maybe we haven't even proposed a project yet? So I'd say that's one other component that I think would be add a lot of value for local jurisdictions.
So, yeah, go ahead.
Just to add to that quickly, and I'll say, because my experience prior to SACOG, I was at the local jurisdiction level and I was their grant writer. this tool could be really important it is important for our programs, but it could also be really important if you are applying for another, like a federal or a state grant, to get really quick, readily available data sets for your project without going through a large modeling exercise or anything else. Plus, like what Darren's just shown you, this could be really useful and is available to you at any time for other grant opportunities. I think we had talked about also maybe tailoring this for some specific grant programs at some point in the future, maybe like the SB1 programs or things like that that might be more specific, but there are some opportunities there. But it's a very useful contextual tool for projects.
I'll just give a second plug. I gave this yesterday, but if you have new staff coming in who are not as familiar with some of these resources and are going to be writing grants, please reach out to our data team, to our transportation team to talk about those, proactively before you're putting something together. We'll take, a couple weeks ahead of the deadline. We always do, but, come to us and really think through these pieces. So like, as Darren said, you can kind of get upstream and look through what are the performance objectives in your grants? How can we think, how can we pull in some data layers? And if we need to bring in others, we have time to do that. So please tell your colleagues and reach out. Any other quick questions? All right, let's hear from Chris a little bit more. And thank you, Darren.
Yeah, thanks, Darren. Nice cue up there. So my name's Chris Doherty. I manage our funding rounds for SACOG. So I'm going to talk through a little bit of how we use this in how we apply it and what the benefits are. We get a lot of really diverse projects come through our funding rounds, everything from road rehabilitation projects to active transportation projects, complete streets, rail projects, bus projects, really a diverse group of projects. It's very hard to really evaluate those projects on an apples to apples basis. For example, the last funding round, we had 83 applications come into our programs. We did award 42 of those, but through our review committees and our process that we go through that, this tool is incredibly important for us to take and score these projects and evaluate some of that quantitative data, but also the narrative data that they describe those projects through. So I'm going to talk through a little bit about how we do that. I'm going to go back to the screen here. So as Darren alluded to, there are, we generally through our applications for our funding round, we score projects through kind of some traditional measures, your project description, risk, deliverability, things of that nature that are kind of cutting across all of our projects. But we use these 7 performance outcomes that are derived from our MTP-SCSs and our general goals and policies as an organization to score projects. And those outcomes are reduce regional VMT and or GHG, reduce regional congested VMT per capita, increase multimodal travel access or modal choice, long-term economic benefit, increase goods movement the region, again, improve safety and security, and also demonstrate state of good repair. So each of these performance outcomes has a particular data set in the PPA tool that is assigned to. So when you select one of these boxes, it's calling that data that Darren has set up and spits it out into that report that we showed you. So for our applications, we ask our applicants to pick 2 of those performance outcomes to speak to, because not every project can speak to all of them. So that helps us kind of level the scoring per project so that we can compare the impact of a transit project versus a freeway overpass or freeway interchange or something to that effect. So that's how we use it as a way to level set a lot of our projects. And then from the applicant side, we ask you to do this for every application that comes through so that we'll see that data come through, but also that data that comes out, you can then speak to that, to the narrative sections in the application that you speak to, or that in part of the application process. So, and even prior to the application process, we do a lot of engagement and outreach to our jurisdictions to talk about their projects, usually 3 to 5 months out before we do a call for projects. We're already out there talking to the cities and counties. What are your projects? How can we help you? How can we help you gauge if they're competitive or not for our programs? Are they maybe more competitive for another program? So we'll run this tool or have them run this tool in advance of that. So we have a lot of context to really talk about at those meetings to help put forward to the best projects in the region that we can. And then from the reviewer side, again, we had 4 different review groups of about 8 or 9 people to kind of review out of our last funding round, these 83 applications that came through. They're generally tied up or teed up and grouped by performance outcomes. So people are, that review group that is looking at more of the reduced VMT, GHG, modal choice, some of those that kind of get packaged together naturally in applications, we'll put those into one review group and rate all those projects together. And they're given a comparison sheet of those projects. There's kind of a special reviewer component that comes out of that through the PPA tool during the application process, which is a really valuable tool for our reviewing committee. So that's how we generally use the PPA for the funding round. Yeah, we can catch up a little bit on time, but I'm happy to answer any questions.
Great. Thank you, Chris. Any questions? Looking online. I have one. Well, it's sort of a question. It's a request. I'm hoping you could, we started off yesterday morning with an introduction to our 2025 blueprint or MTP SES. And I was hoping you could speak just a little bit to kind of how the PPA tool brings in some of that long range planning perspective and sort of coming back to, we would talk about SACSIM, just kind of how some of these pieces fit together. Where does long range planning data show up in PPA?
So the PPA, I'm not gonna try to share. What you'll see on that report that gets spit out is a great example is that kind of jobs and housing around the project. We're going to give you data immediately for the base year of the project of the plan. And then also the horizon year of the plan. So you're going to see, I think in this case was 2020 to 2040. You're going to see the growth and the changes in that area based on that project. I think give you a really kind of good snapshot. But then also the data that comes out of that, all of these policy goals and outcomes are driven directly from our long range planning exercises and how we get to that 19% reduction in GHG region wide is, but also balance our economic development, goods movement, safety, and just those local regional needs around state of good repair. So these outcomes balance all of those things. So we can then use this through our funding round and judgment to balance our needs with our funding.
Great. So you can take a look at that tool and it says, here's what we have sort of now in our base year. And then here's what we expect that land use and sort of jobs and housing match in 50 years, right? And it doesn't say what the project's going to do. It asks, you tell us what your project is going to do given these assumptions.
Yeah,
so awesome. Great.
It's not no project analysis, but it is a contextual analysis around that project. So you can, like the safety data we saw, you can then address in your narrative saying, yes, we have safety issues around these intersections on Broadway and whatever street that was. We are going to be making improvements to those intersections to slow traffic down, daylight the intersections, all those things that you can do to really address those specific safety issues there. So the pairing of that quantitative data that the PPA spits out, along with the narrative and qualitative data that we ask our applicants to describe, kind of really does make our applications better.
Great. Thank you, Chris. Give him a round of applause. Very good. All right. And we will make sure that everyone gets the slides and the links. You can go and play around with the PPA tool. If you want on a real project, a theoretical project, kind of see what comes out. Okay, it is time for a break. It is just about 10:12. We are going to come back here in about 15 minutes or so. I'll give you a little bit more. Let's say come back at 10:30. Right, it's a little bit more than 15 minutes. We'll come back, talk about data sharing and scripting, and we'll hear again from Ibrahim on how to request data and a couple more use cases. All right, 10:30, please. Thank you. So I'd like to invite our next presenters up. We have Darren's going to come back up here in just a second. And we have a new presenter, Josh, who both are at SACOG. We are excited to hear from them. Excuse me, about data scripting and sharing. You can come up here. Mm-hmm.
Then I have to wait for Duo to let me go.
No problem.
Thanks.
Let's see who's still with us. Oh, we have more. Okay. Great. We have more folks online than we had early this morning. That's a good sign. We're missing some more folks that we saw here in person. Hi, Dave. Let us know, please. You had a lot of questions yesterday. Thank you. If you want to share again today in the chat, that's wonderful. Wonderful. Shout out to some of my SACOG staff who are at their desks just tuning in. I'm sure they might be at home, so they might be at home. All right. Josh, do you want to introduce yourself while Darren gets set up? I'm gonna just scoot over for a second.
Hey everyone, I'm Josh. I'm probably the newest addition to the DAMS team here at SACOG. Background in statistics and geography, I'm here to just help with some Python programming, speeding up some stuff. Specifically, today I'll be talking about the regional monitoring program and kind of some of the analytics behind that going on right now.
Great, thank you. All right. Oh, and I forgot. I have a poll. You want me to do my poll? The GitHub poll? Let's do it. Okay. It was me this whole time. Okay. All right. Darren's ready. I'm gonna do so there's a QR code on the table for new folks. It says poll on it. And you should be, hold on, give me a second. You should be able to open it up. I will drop it in the chat in just a second for our folks online. Here we go. So
It's not, it should be, it says I'm sharing my screen.
it's okay. We're gonna get there. If you all do, does it work on your phones right now? Are you seeing? Yeah, just do a little refresh and enter it in there, and then it's going to be my turn to share. Sorry, Darren. Here we go. Oh, come on. Okay, yeah. Oh, so we've got, have you used any of SACOG's GitHub repositories? Oh, sweet. Some folks have pulled files from one or more SACOG GitHub repositories. That's great. Hold on, I'll get you there. Hold on just one second. Here we go.
Darren, I think if you compare that to last time, we're like 500% higher.
Oh yeah, it's proportionally, maybe even be infinitely higher.
So apparently we are infinitely higher. Let me get it in the chat here. My apologies. Okay. Everyone, if you want to check out this link, it should get you to the GitHub poll. Okay. Great. Okay. So a majority of us have never used GitHub before. That is okay. Some of us have pulled files. This is very exciting. And a couple more. All right. Hey, well, we're glad to know kind of what's going on for y'all, and we're going to learn more today. Hopefully you might answer differently after this presentation and maybe in a couple weeks after that. All right, go ahead, Darren.
Alrighty, let me just get my screen back up here. And let's see how that looks. That's looking good. Excellent. So yeah, I just kind of would like to walk through some of the repositories and features with my colleague Josh here. And this is not going to be an exhaustive walkthrough of all the repositories and tools on SACOG's GitHub. It's going to be some that in our opinions or in our judgment, we think have the most potential to be useful to the SACSIM user community and also the data analysts in the room who use SACOG's data. That said, I do encourage all of you who are interested to definitely go through all of the repositories and explore them and see if anything there could be of use to what you all do. Let's see. So today we're just going to focus on why SACOG decided to set up a GitHub several years ago, back in 2021. And we're going to walk through two of the many repositories, the regional monitoring repository, which Josh will walk through, and it's sort of the engine behind the regional monitoring report that he and Garrett talked about yesterday. And then I will walk through some of the tools that we have on the SACSIM 23 repository that are very useful for working with SACSIM data. Why did we set up a GitHub? Well, first off, efficiency. Before GitHub, we had lots of different scripts scattered over various shared drives, different versions. Sometimes we would reinvent the wheel because somebody would write a script and then they wouldn't tell anyone, and then another person would write the same script. GitHub is a nice place where we can go to one location to look and see what's been done. It's organized efficiently. It's very easy to share both internally and externally because you just share a GitHub link. Oh, a little quiet. Okay. And so there's a lot of efficiency reasons that just make it easier to share and work with code using GitHub as opposed to our previous system of just using different scripts scattered across shared drives. There's also version control. Previously, we would have a lot of oh crap moments where we forgot what we did to change a script to make it no longer work. GitHub allows you to use a lot of use a commit history to easily and efficiently go back in time to specific points in your script. It also allows you to work simultaneously on the same script through branching. So it just operationally, it makes working on scripting processes more efficient and also just more fail-safe or able to backpedal if you create an error. There's also transparency. As a public agency, we have a responsibility to share all of our methodologies, and the public has a right to know how we compute and process a lot of our data and arrive at our conclusions. And by sharing our scripts, we fulfill that sort of spirit of transparency. And then related to transparency is also methodology sharing. We do a lot of summaries and work with regional data that I believe a lot of cities, counties, and consultants regularly do. And there's no reason that any of us should have to reinvent the wheel on scripted processes. So we like to share the scripts in the hopes that people in the community can use the scripts or copy piece snippets from it and hopefully save themselves some work reinventing stuff that's already been done. And with that, I'll pass it off to Josh to talk about the regional monitoring repository.
Great. Awesome. Thanks, Darren. So yeah, today I'm going to talk about what we have available through the regional monitoring project. This was something that Garrett and Pete discussed at length yesterday. Historically, we've had the progress report. I have a link to it there. And going forward, we'll have the report, but also have a dashboard. Have something a little more readily updated regularly as opposed to like every 3 to 4 years. And I'll just briefly, this is about tracking indicators throughout the region to help with long-term planning. So education rates, for example, annual population growth, congestion, safety metrics, a whole bunch of different indicators from a range of different topics. On GitHub, what you'll find is lots of Python code. So this year and going forward, we wanted to automate things so that whenever new data is available, instead of going through this manual chugging process of Excel and downloading data from all the different data sources, we just wanted to automate things and make it real easy for updates in the future. And so the way that this repository is organized is by data source. We collect data from Census Bureau, BLS, Zillow, a whole bunch of different data sources. So to keep everything organized, I put it out by data source. We have code and configuration folders specifically for the data sources that rely on an API, which is an application programming interface. And for those data sources, we've built data pipelines in Python. So a streamlined process that goes from data collection through cleaning, data processing, all the way to exporting to the dashboard. That pipeline for those data sources with an API kind of has 4 steps. We have an importing step, a processing step, a data visualization step, and then an exporting to dashboard step. That first step is a little more commonplace. Like anyone can kind of jump in and use um, this pipeline with some practice and import data really quickly. If you've ever downloaded data from Census Bureau and you need to download 10 years of data manually, it's kind of a pain. But this is a streamlined approach to doing that. Steps 2 through 4 are a little more specific to how we're processing indicators, how we want to group things together, and are maybe a little more specific towards our goals. But in general, just like an example with an API, and I'm going to talk about the Census Bureau specifically, but BLS is another data source that has an API. It has a similar structure to this. From the Census Bureau, there's different samples you can pull from, like ACS or PUMS. Those are 2 of the really popular ones. There's a whole lot of other ones that you can pull using their API as well. The link to what data sources are available, and the Census Bureau does a really good job of organizing how their API works, and the link to it is right there. And just like a simple example, this is an API request query. So this is something you could type into your browser. You have your root URL that kind of tells you what year and what sample you want to pull, the variables you want to pull, and then for what location, so county and state in this example. And in Python, you can kind of just build this and piece it together using f-strings, like kind of a real simple approach, and the requests library in Python. And you can build this out. This is just 2 lines of code out of like thousands of lines of code at this point. But this is the main idea with building this out. And using a simple for loop, you can pull lots of data, concatenate it together really easily. And for this pipeline specifically, how do you configure which counties, which variables, which sample you're pulling from? We have a host of different agent files, just using Excel for now, of how you might configure the pipeline. So the top left table just shows like, okay, which sample are you pulling from at which geography? Do you want margin of errors or no? Like what years you want? We have a table for geography, so like which states and counties you might want to pull. And then we have a variables table as well that just shows, this is for the Census Bureau specifically, which table ID, which estimate IDs, and whether you want to include them or not. And these are all kind of linked together into this pipeline here, and to build this query. It's a work in progress, but it's worked so far decently well. And that's just kind of a sneak peek at kind of how this how you might use this this tool. So with that, I'm gonna hand it back over to Darren.
Thank you, Josh. So yeah, I'll walk through some of the tools in the SACSIM 23 repository. They're not especially exotic or new concepts in modeling. I like to think of them more as useful, potentially productivity enhancers. The first one is our Quick Ag tool, and it's pretty straightforward. It runs as a toolbox in ArcGIS Pro. It has 3 inputs, which you see in the image on the left. You just copy paste in the model run folder path, and then you enter a path to a DBF for highway links that have the VMT on each link. And you also enter in a scenario description. It can be whatever you want, just to kind of help you identify, maybe describe what are the assumptions of that scenario. And then you hit a run key, just hit a run button, and then usually 30 to 45 seconds later, you get a CSV produced, which has essentially the table on the right. You don't have to focus on looking exactly at what the table says, but basically it is this tool is a very fast way to go from having a completed SACSIM model run to having executive level model results, i.e. the results that the SACOG management team always wants to know. Results where if we made some change to the model, do we immediately know that the results are reasonable, or if we have to check one of the inputs? It's just a very fast way to get outputs. So like total population, total transit revenue hours from the model run, total VMT, both from the roadway and also generated by residents. Then also a breakdown you can see with all the trips rows there, a mode split. So it's just a very quick way to get some of the most frequently asked for numbers from a model output. This is one that Kyle worked a lot on, and it's a base future network comparison. It might, and I would allow Kyle just to correct me if I'm wrong, you could maybe alternatively call it a scenario comparison as well. But base and future is a very common comparison that we do. And so what you do is the inputs to this tool are, and it's a Python tool, you input 2 different highway net files from a model run, and it will do a comparison and show, export it as a GIS feature class, and it can be comparisons for lane configurations, comparisons for traffic volumes, congestion levels, comparing both inputs and output assumptions. And the idea of making a map like this is not new at all. I mean, anybody who works with Cube probably made a lot of these in reports. The virtue to this tool is that it takes Cube inputs and with a single step outputs Esri compatible GIS layers, so like feature classes or shape files. And this allows just very quick access to Esri's much richer array of like symbologies and ability to like publish it as a web map, and other, basically making it more accessible outside of sort of just the Cube environment. So that's another tool. There's the transit line to GIS converter. This is, it takes in a transit line file, a .lin text file, and outputs it to a GIS file, and basically a shape file with data on such as frequencies, route type, who's the operator, that sort of thing. And it allows, and the creation of this script was really out of a demand for creating maps showing our transit system, or maps showing where all our high frequency transit lines. And this just makes it a much faster, more efficient process than it used to be. This is also related. There we have our major transit stop identifier script. So what this does is, I guess to back up and give some context, there's a number of laws that have been passed over the last few years, such as AB 2097, SB 375. And these laws are trying to incentivize building housing near quote unquote major transit stops. It does things like reduces the amount of CEQA processes you have to go through. In some cases, it even preempts or gets rid of parking requirements. And so there's a lot of interest in, all right, well, where are these major transit stops that make an area qualify to be for streamlining under these laws? And this is a script that takes a SACSIM transit line file as an input, and it will, as an output, it creates a point file of specifically major transit stops. And it also has several parameters where you can do configuration to say, well, how do you define major? You can usually major is based on a common one, or like if it's a rail stop, it's automatically major. If it's a bus stop, if it's an intersection of 2 bus stops where each bus stop at the intersection has a headway of less than 15 minutes, it's major. If it's tagged as BRT, it's major. And so this script takes a lot of those different factors and outputs for, depending on which law you want to analyze, you can adjust it to show what stops qualify as a major stop under that law. Here's another one that my colleague Ibrahim put together called the SACSIM Run Catalog Tool. There's 3 key things that it does. it compares model run inputs and it logs which inputs differ. So sometimes we've had unexpected results from a SACSIM run, and we were certain that we didn't change anything. Well, this is a very systematic tool where you can just run it and compare all multiple dozens of the SACSIM input files and make sure that they are identical, or it'll flag which files differed. And it's helpful for diagnosing sort of unexpected results and making sure you're copying run inputs correctly. It also archives unique versions of different model run inputs. I'll show a slide in the next slide what this means, but it's very consequential if you have recurring issues of having sufficient storage space for model run inputs. And sort of from those unique versions, you can reconstruct model scenarios from the archived inputs. To kind of go a little more into what that archiving looks like. So let's say you have an example where you have 10 model runs. Now, every single model, each one of those 10 model runs needs, for example, a parcel file. But let's say that for 9 of those 10 model runs, the parcel file is the same. That 10th run, you made some land use changes, so it's a little different. But 9 of those 10 parcel files are the same. So ideally, you don't want to have to store 10 parcel files. You should ideally just have to store 2 of them. So what this does is, let's say that you largely don't need these inputs anymore, but you might want to reconstruct this model scenario in the future at some point. You can run a script that will basically iterate through all those 10 model runs and flag which ones are unique. So using this parcel file example, I highlighted in this screenshot here that out of these 10 model runs, there's 2 unique parcel files, and they're tagged as unique based on the scenario year for example 2016, and then also the last updated timestamp. The assumption is that let me go back one. If you have the same scenario year and identical update timestamps, that it's likely the same exact file. And so this is just sort of a way where instead of having 10 copies of the parcel file, you only have the 2 unique ones. But based on that unique code from the scenario name and the timestamp, if you want to rebuild any one of those scenarios, you can. And it's sort of a benefit. It just saves a lot of space in some cases, up to 80 to 90% less storage space. This is probably the weediest of the tools out there, but it's a Python wrapper for Voyager scripts. It leverages Python's subprocess module to call and run Voyager scripts from within a Python script. It streamlines a multi-step workflow into a single step. And as an example, that transit line to GIS converter script, and also the network BiFi base year, future year script, those both leverage this wrapper concept, in which traditionally, without this wrapper, if I want to convert a transit line file to GIS, I would need to take a highway net file, open Cube, convert it to a DBF point file, close Cube, and then open a Python script to link the transit line file to the DBF point file. But now I can do all those steps I just described in one step, because this wrapper will run a Voyager script through an automated process. It does that file conversion instead of me having to open up Cube to do that conversion. We've so far just used this wrapper concept for basically file conversions, like converting Cube files like net or .lin into file types that Python can read in, such as CSVs or DBFs or what have you. But it could be used for any Voyager script. For example, in another process I'm working on, I create a summary showing aggregate changes in person accessibility to jobs or what have you. So that instead of having to run a Voyager process through Cube and then run a Python process to aggregate the Voyager process outputs, I just run a single Python script and it does it all in one go. These are the links, and as Alex has mentioned, everyone will get these slides, and you can access all these tools through the GitHub links. And that's it. Like I said, there's more on our GitHub, and I encourage you all to review it. But these are some of the highlights.
Great. Thank you, Darren. Thank you, Josh. Give him a round of applause. Wonderful. Lots in there. I just have to say, all of our presenters, you are really delivering on the technical side of this. It's really wonderful. No, that's what we're here for. Any questions? Any questions? High level, specific? Yeah, go ahead.
For the quick ag, is there a way to do like sub area aggregation, or is it just the whole model?
This is for the entire region, but this is one of the great things is that if you have folks in-house that are savvy with Python, it's a great jumping off point to make customizations.
That was actually my question earlier on. I had that thought. Very good. All right. Anything else? Okay. Quick show of hands in the room. Who's going to get on the GitHub? Come on, put them up. All right.
honest.
Yeah. Okay. Okay. Yeah. Yep. Push it and it turns green and then you can just leave it
Green. So some cities, we don't have folks who specialize in Python. What resources can SACOG provide us to help us?
Well, I would say part of it would be maybe through it depends on what the ask is, right? Like what is it that you would need that would require, perhaps some assistance with Python tools or what have you. I would defer to Kyle if he has any if I'm misspeaking on this, but one option could be through the data request form that we talked about yesterday. That's usually a good starting point. It depends on what the ask is, right? Sometimes it could be a huge workload, but in some cases we have run analyses or run these tools ourselves on behalf of jurisdictions. If it's like a simpler ask, but it depends on what the ask is.
But you should ask.
Yes,
Definitely ask for help. Absolutely. That is something that we all have to see, but I'll let Kyle talk a little bit more about maybe some specifics, but please don't let that be a barrier if you want some support. And I'm just going to, in just one second, Kyle, because David asked the same question online. For those of us not so great with Python, are there online instructions in the GitHub for helping with implementation? We can take that in a second, but definitely for our member jurisdictions, we offer all kinds of data services, so please reach out.
Yeah, thanks. I think that's right. So we've gone back and forth on this. I would say in general, we feel comfortable that we are a Python shop. We do a lot of our work in Python. That's not to say all our tools are developed with Python. It's great. It's a kind of a data science industry standard, if you will. We have plenty of other things in R, just Excel spreadsheets, a lot of GIS tools. So I think if you're not comfortable with Python, which is totally fine, just come out and ask us and we might have some alternatives. I know Ibrahim's going to talk a little bit about how we do our population synthesizing. We have tools that are in Excel for that, in Python, in R, and really we just try to be transparent with the tools that we're using and sharing those, but it's not to say that you have to do it one way.
Thanks, Kyle. And then another question, are the GIS tools online as GIS projects?
So the only one I believe that of the ones that I went through, the only one that is out of the box like an Esri GIS product is the QuickAg, which is a toolbox for a toolbox TBX file that you can open in ArcGIS Pro, but they're not like an APRX GIS file.
Great. Hopefully that
the BiFi is also a toolbox file. I don't know if they are openable in ArcMap, but they definitely are openable in ArcPro.
Great. Okay. Another question. Yeah, in the back. Don't forget to turn on your mic, please.
Yeah, I wanted to ask about VMT, and since VMT is the focus of Caltrans after SB 743, I wanted to know whether there are scripts in GitHub for different types of VMT and whether they're user-friendly for someone who wants to extract the script and use it to run for a certain area.
When you say different types of VMT, like, or what
Yeah.
would be some of those different types?
Yeah, because for example, now in the OTP of Caltrans, we work with 7 or 8 types of different VMT, one being work VMT or the total VMT or home-based VMT. And I wanted to see whether it's classified like this there.
Among the tools we just went through, there is roadway VMT, which is just everything regardless of purpose or vehicle type or what have you. And then this is the quick ag tool, and it also has residential VMT, so that's all VMT generated by all purposes, but only generated by people who live within the region. I don't know if we right offhand have scripts for things that specifically talk about like that isolate like home-based VMT, but that would again I think be a good the data request form would be a good jumping off point if you'd like to learn more about that. I think we got another.
Great. Go ahead.
Darren, one resource for that might be scripts we've already created on the projects like City of Sacs General Plan. I think we did 7 of the VMT metrics, and those scripts, those are available if anybody wants those. So I think through the different city general plans or 743 efforts, scripts have probably been written for every single one of them between a few of the consultants. So those should just be made available if you want them.
Okay. Yeah, that'd be great. Thank you.
Great. We have one more question online. I'm going to invite Dave to come into as a panelist here for a second. So Dave, are you here with us? Can we hear you?
Yes, can you hear me?
Yeah. Talk right into your computer mic.
Okay. Can you explain, like, I thought that network comparison that you brought up in ArcGIS was great looking tool compared to a lot of the stuff that we typically do. Can you kind of explain how, just really quickly, how we would implement that tool, what that would look like?
Right. So I might call on my colleague Kyle because he wrote the tool. Kyle, if you want to take a first stab at that one.
Sure. Yeah. We call it BiFi, meaning base and future, but really it's just a comparison chart. So you're able to have 2 scenarios and compare a variety of model output metrics that we look at. So in particular, VC ratios, volume changes by period, time of day. We also incorporated a few other metrics. I don't recall all of them, but the big change that we did is we took what we had previously written in Cube Voyager. So you get an input from our modeling tools and it's an output in our modeling tools. And we converted it to Python to have the outputs be in ArcGIS or ArcPro. And so then it's packaged up in a GIS toolbox. So you don't need familiarity with particular cube packaging software and scripting, and you can visualize it, which I think we could probably all agree Esri has slightly better visualization tools. And so it's allowed us to make a lot more web maps of the results of our modeling outputs. Great. And then I did want to add a little pitch for the catalog tool. That's something that stems from past user conferences, that these modeling files are huge and it's really difficult to manage all of it in the storage space. So this was a great solution that it allows us to manage, remove all that unneeded space of duplicates, but then also track the files as projects continue to go. So I encourage you to use that if you're a practitioner of the SACSIM model itself.
Thanks,
Am
Kyle.
I still unmuted?
Yes, I was going to check in with you, Dave. Anything else?
Yeah, I guess, Kyle, what you were answering is kind of like what you can do with it. I guess my question would be, and I don't think you have to answer it now to the whole group, but maybe if we could just get maybe a step-by-step of how you would implement it? You know, do you, like, it looked like there were folder selection, but you're selecting, you know, are you opening it in GIS to begin with? Are you opening it in a Python editor to begin with? I'm just not 100% clear on how you open it and work with it. And you can mute me. It sounds like there might be some feedback.
Yeah. So no, it's a great question, Dave. So it depends on the script or it depends on the tool. So the toolbox ones, generally you just import the TBX file into Pro, and you should be able to run it through Pro. Some of the other ones, they're set up to where you would need to run it in like a Python editor, or if you ran it in the command prompt. A lot of them, they're set up so that they have like the Python input statement. So if you just run it in a command prompt, it'll say, and enter the path to the transit line file, enter the path to the model run folder. So those are the primary ways to interact with the tools. The one thing I would caution though is that a lot of them, be mindful of the dependencies they have. So like a lot of these tools use like pandas, they rely on ArcPy, they rely on a number of Python libraries. So if you get errors, I mean, those Python's usually pretty straightforward about telling you're missing such and such library, and you can install it as needed.
Great. Thanks, Darren. And Dave, definitely reach out to us if you have other questions about that walkthrough. We're happy to help with that. I'm going to send you back into the attendee list. Thank you. All right. Any other questions in the room? Otherwise, we're going to keep moving on. Okay, great. Thank you again, Darren and Josh. Round of applause. Fielding those questions. Okay, so Ibrahim's going to come up again and share a little bit more about trainings in Info Center. And you've heard a little bit about it. We've said, I think, a number of times, please reach out. We're here for you. And here we go.
Yeah, hello again. Glad to see a lot of the faces we saw yesterday and a few new ones. Today I'm going to talk again a bit about the data requests process and some of the resources that we have, because that's our main way of interacting with you and sharing with you. So I'm going to share similar slides to the ones we had yesterday and add some new examples of projects that we've recently fulfilled the data requests for. That might give you a better idea of what's available, what's out there, and what you can ask for. So your main stop is the Data Resource Center on our website. Try to check if we have the information already on our open data portal that has multiple resources available in it. And then if you're working with our travel demand model, I know it might be, it has a lot of sub-processes, but if you go to this page, you can really go into details into the different types of processes, and there are really detailed step-by-step guides on how to use them. And if you go to the guide, find the step-by-step guide, and you still can't run a specific process, reach out to us and we can have a meeting and work through that. We have a full model user guide that, in addition to giving you instructions and steps, gives you some background on why we're doing these things and theoretically what's happening. Darren today touched on our GitHub, and if you go there, there are a few public repositories available, and you can access like transit scripts, our model network scripts, land use preparation scripts. They're sectioned off that way. We are working on getting our SACSIM 23 repository out. The SB 743 page has a lot of support and information here. And definitely, if you want additional support on this, reach out to us and we can work on setting something up. So if you want to request data, either contact a SACOG staff person, but the fastest way to get in touch with us and get somebody to help you with your request is to fill in a data request. Filling out the data requests helps us understand what you need and what you're using the data for, and helps us put you in touch with the right staff person. So who can request data? As Alex mentioned today, our member jurisdictions are highly encouraged to contact us when they need support. And consultants, if you're working on a project in the region, we're also happy to help with those projects. Environmental organization, educational institutes, and everybody basically is welcome to send us a data request, and we'll take the requests as they come, and we'll consider them on a case-to-case basis. So you to request some data, you go on the website to the data request form. You put in some information. You sign in you sign a release, and give us your contact information, the information we can reach out to you on, and then give us information answering three main questions. What data are you requesting? How are you planning on using this data? What kind of analysis do you want to perform on this data? This will help us understand what kind and at what level of detail you need it. Also, if you can identify which project or general plan you're working on, or if you're working with a member jurisdiction and this is a project to support their general plan, for example, that is very useful information to us. It'll help us put you in contact with the person that might have already started some of the work on working with that particular jurisdiction, and they might have better knowledge and be able to get you the information you need even faster. So you can give us very general information or very detailed based on what you want or what you know that we have, and and that will really affect how fast we can get you the information you need. But in general, you can expect a quick response from us, just even if it's just to acknowledge that we received your request, that we're connecting you with the right staff member, and once we get that connection done, we can reach out for additional context, detail, and maybe understand more on your timeline. If you are a member jurisdiction or consultant that is on a very tight deadline for something, that would be very helpful for us to know. So the types of data you can request ranges from GIS layers, housing data, travel data, model run files, even trip tables for completed model runs, if you want those ready-made. Some examples of projects that we recently fulfilled that we didn't go through yesterday include model run files for a prospective rail stop study somewhere, I think it was in downtown Sacramento. Parcel level job and housing information for a job analysis. Number of commuters ending in a certain block group. Population projections, and this was for a water needs study, so not necessarily transportation. It was they wanted the population projections to figure out how many people are going to live in this area for understanding their water needs. There was also a request for GIS files for residential VMT and work tour VMT for an SB 743 analysis. Also, we have some collaborations with some universities and researchers. For example, I think UC Irvine has a project that is in partnership with SACRT, and they requested some trip tables and model run files because they wanted to study microtransit, for example. So these are the kinds of things you can request, and I hope that gives you a better idea of what's available. We also provide trainings. I got some questions whether or not these trainings are recorded. Usually what happens in these trainings is that the consultants have an idea of how to run a certain process, and they want to fill in the gaps, or they want a training on a specific sub process within the general one, and we work with them on how to achieve that. Also, some of future trainings we have coming up include using a new land use updating tool that will hopefully make updating land use a lot easier for our jurisdictions and their consultants, or even researchers. Also on SACSIM 23, we're going to release a new guide, and hopefully we can work with you on
covering some of the gaps that you might find there. Also, we have our 743 support page again, and just feel free to reach out to us, to a staff member, to our SACSIM email. All these ways are a good ways to getting in touch with us and for getting the process started. Yeah. All right.
Great. Thanks, Ibrahim. Glad we could share for some of the new faces in here today and probably online. Any questions? Nope. Okay. I don't see any online. Let's keep going. Thank you again.
Yeah.
What? Oh yeah. Yes, Ahmed in the back.
So you mentioned that the new guide is coming up for SACSIM 23. Do you have a rough idea of when is that going to happen?
I would refer to Kyle on that one. I think we're gonna start releasing the paper.
Yeah,
soon.
likely fall of 2025. It will be released with the blueprint. But if you have any specific questions, we can follow up ahead of time. But SACSIM 19 user guide is sufficient, but we'll provide additional details that we've been listing throughout the conference, such as like telework and different changes. So if there's any specific questions prior to that release date, come talk to us.
Thank you.
Great. Okay. Thanks again, Ibrahim. Give him a quick round of applause. Very good. Okay, so we have one more thing we're gonna do before we do lunch, which is fun. It's it's only 11:15, so that's good. We want to talk about tools. Do you go to the next slide, please, Karen? All right. So we are going to get together in groups again. I heard it's very exciting. I heard some folks sharing the tools that they have developed, their own jurisdictions or other resources that we want to share. That's wonderful. We want to have you all talk about what other needs you have and what that looks like in a tool potentially for us to think about and see where we could take what we currently have. So it might be iterations on what you have seen today, like, oh, it'd be really great if this tool did this thing, right? Just add on another aspect of it, or we want something totally new. I can't promise anything from the data team on what they can deliver, but all this feedback helps us. The only way we can be responsive to what you'll need is by you telling us, hey, these are the challenges that we're facing in the work that we're trying to do. Okay, go one more for me? There we go. Okay. So we're gonna in small groups at our tables, right? We're going to briefly reflect on what we've learned so far and what unmet needs you have. Talk about potential tools or solutions to your data and modeling challenges. And then if you could, there's some paper on here. There's Post-its. There's also, which you can use if you want. There's also this sort of graph paper. If you could at your table just document those on one piece of paper, and then we're gonna share out. Just make sure we got a little bit of notes at each table, but we'll come around. Okay, we'll go for a couple minutes at the tables, and then we'll break it out. It's a relatively small group today, so I think we'll have time to hear from everybody. All right, is that clear? Your prompts are on the screen. Any questions on the breakout? Okay. Wonderful. So if y'all will start, for folks online, you can also participate. You are welcome to look at the prompts, think about them, and share in the chat or in the Q&A with us, and we will bring those into the conversation when we share out. Okay. Let's go. I'll check with you in maybe about 10 minutes or so. 2 more minutes, 2 more minutes at your tables, and then we'll share out. All right, let's hear what folks have to say. Oh my God. All right, we're gonna go around. Thank you to the folks at the tables who took some notes. If you didn't, that's okay. I'm gonna chart some ideas up here while you share. So let's just go around. We have some time. We want to hear what you talked about, and if you can kind of highlight. You can talk about across the things, but really highlight some of the if you have sort of key asks or key feedback that you think is important. That would be great. So I'm gonna ask Kyle actually to start over there. I'll take notes for a little bit, but just with this table, we'll just go around. Yeah.
Right.
Lucky first group, and you can. Yeah.
So I can help you all out, but maybe just if you don't mind discussing a little bit, what is the needs you have? Do you have any solutions in mind that SACOG can help out with? I know I heard some VNT requests earlier today. Oh yeah, you got your own.
Yeah, so I have several points to make. Yeah, I'm not sure how to import a cube network file in ArcGIS Pro and projecting it along with a base map. Similar to those that we see in Google Maps. Plus, as Caltrans employee, I do have difficulty trying to project those route and post-mile information on SACSIM network files. So that's another bummer. And my suggested solution is to have a script or scripts just to address both issues. And my third point is, yeah, SACSIM 19, that's actually my neighbor's, yeah. Point. Yeah, SACSIM 19 is not really representative of today's conditions because now the pandemic is over and a lot of companies are either back in office or hybrid teleworking or completely teleworking. So I'm not sure if SACSIM 19 is the best course of action to take, as in to apply the SACSIM 19 model. So I don't have an answer for that.
Great. Anybody else at that table?
Yeah.
And I didn't write your specifics because I didn't catch them all, but we will get them. I promise. But I heard scripts in SACSIM for a couple of key processes that are challenging for you. We got it.
Yeah, just to add on the third point that, until now in the year 21 and 22, we were thinking that the trend of traveling of 2019 is going to continue someday. But now it seems that a new work culture has developed. And beside that, we have other technologies like EVs coming into play and maybe complete streets having a role. So surveys are going to have to reflect that and help you in development of SACSIM, that the travel patterns are changing, and maybe in 27 we're going to have a very different traffic from 2019. So it might need a drastic change at some point with so many different inputs entering, from telework to EVs to change of to the younger generation wanting greener modes and all these things. So it's going to impact the mode choices.
Thank you.
Alex, if you don't mind, I think
Yeah.
that's a great question, and I'd love to open that up to the room if anyone else has thoughts on that. Kind of with our tools reflecting for forecasting based on how folks travel today or even yesterday pre-pandemic. How are you all dealing with that or wrangling that with that question in your projects?
Good question. What do you think? Yeah, go ahead. You can, yep.
At least for us, this is Ron Milam, a productively paranoid consultant. So a lot of our projects get legally challenged. So if you get this kind of question, using a model that was calibrated to pre-pandemic conditions is not an ideal starting point. So right off the bat, we've got to make some type of refinements, do some types of checks. So like one of the things that, like SACOG could help out here is with data sets like your replica data set, where you can do a longitudinal analysis to go back and like look at, hey, how has VMT per capita changed between 2019 and 2023? And same thing for volume checks, so that we get some type of verification if there's been enough of a change that we'd have to make an adjustment. So you guys already have that kind of data, so putting that out there in some published form that people could see it either at the TAZ level or select freeway corridors. Things like that is like the starting point for that. And then depending on the nature of the project, whether you're trying to design a Caltrans facility or doing a general plan update, the details might vary a little bit.
Great, thank you. I'm just going to ask, ping Imerhib if you want to take some more detailed notes. If you can, that would be wonderful. Yanmei, did you want to share something about that? And partly what I heard is, so we have some existing data sets that kind of help us monitor, right, the potentially growing gap, or, kind of the pieces where it's no longer reflecting. So making sure we have kind of, for all of us to think about, like, that monitoring in place. What are the practices that we're doing so we can then change if we're starting to see that gap widen? Is that right?
And even doing it for your like regional analysis districts.
Sure.
One of the things we know with like telework, the research is mixed on telework. Sometimes it reduces VMT, sometimes it increases. What we found is in places like Placer and El Dorado County, where you had some longer distance suburban commuters, if they replace the commute, with telework, and they still make a couple of local trips,
right?
It was such a long commute they replaced. It's a reduction. But if they were in North Natomas commuting to downtown Sacramento, and now they're making 2 more trips to North Natomas, no, it's a net add.
Mm-hmm.
And then if they had kids, was a big factor too. The whole household might travel more if they're home. So yeah, to the extent that you guys are doing things in a geographic type evaluation of that longitudinal trend, that would also help.
Yeah.
Thank you.
Yeah, I just want to want to respond to that. We are actually kind of in the process of being kind of work on.
Hold on 1 second, Emily. Yeah. You just, there you go.
Share like more the data from replica. Yeah, just I think yesterday there's a presentation, right? Right now we are kind of subscribe, kind of replica data for at least for 3 years now, but we have a 5-year budget secured. So we are actually in the process. We already assembled some data set, the idea to share like a network volume, right? Like by different types, across like 2019, 2021, 2022, 2023, we have all data available now. That's kind of in assembly. We just need to kind of develop a web app, to share that public, or like a household generated VMT, right, by block groups, right? That's their kind of the base geography. That's kind of, we already kind of work on those things, we will share with you guys,
Great.
Once that can be published,
Thanks, Anmei. Let's keep going around the room. We'll go to the rest of this table. If you have other, we'll go this way, because since we went this way anyway. Other things that you all talked about that you want to make sure we hear about.
What I have is about PopGen tool in SACSIM 19.
Okay.
So sometimes we run into accident about the need to reinstall the PopGen tool, and we understand like the tool requires multiple softwares like SQL and Python, and the version of the Python for PopGen date back to 2012, which could sometimes cause issues. So I'm more wondering about, so for maintenance of the PopGen tool, or maybe it will be needed for updated version of the different softwares needed. So that's the.
Thank you.
I can put a quick pitch in to stay this afternoon. We do, I think, have a solution. I think even more than a Band-Aid for that.
Yay. Great. Anything else from this table?
So from my wish list, one is I want to break down the post-processing summary that we have so we can summarize into jurisdiction like city or county levels.
Mm-hmm.
And then another thing is I do work on a lot of track projects, so I would want to learn or understand a little bit more of the track model that SACSIM is using.
Did you say truck model?
Yeah.
Okay. Great. Okay. Warren? Okay, great. Warren, we'll get, if you would invite him into the room in just 1 second, and then, truck model. And so make sure you get on your list, you have on your paper, write some of this stuff down, and we'll get it all. Okay. Anybody else at this table? Okay, we're going around. Okay.
Sure. So mine's less about the SACSIM model and more about just a data challenge to help with a bunch of developers. Is there a way we could have like a map of all the blueprint projects laid out on it via GIS with data? So I don't have certain people calling and we have to look up stuff line by line and tell them what projects are in or out.
The transportation list.
Yeah.
Yeah, I hear you. So the request to have a map of the transportation list instead of just a table. I think we're thinking about the best ways to provide that information in what is the package of the blueprint. So I can't say for sure what all of those products will be, but we are definitely thinking about for different types of audiences, right, who need different kinds of visualization products, what's going to be most useful. So if we don't get it in the stay tuned. And I think staying tuned with us about what, if we have some conversations with some of our, partners about what they need, I think when we get closer to that final document, we can also then talk about, can we help you with the data that we have? Can we transform that for you, right, in the context that you need?
Thank you.
Yeah.
I think I would just add, similar to the model documentation, we'll likely be releasing some maps like that with the release of the plan in 2025.
Mm-hmm.
But we're in the works with those. So if you need particular help on a given project, contact us and we can get somebody to help kind of run that show for you.
Thank you.
Yes. Yeah, Warren.
Hey guys, Warren from yesterday for Replica. So that gentleman in regards to the replica data, like as a baseline check. Now, what we have is for pre-pandemic is only fall 2019 data. And moving forward, we do have data from work from home and also EVs, but I'm just a cautionary in regards to the sample amount of data points that we have from Replica, which is really they're confident in their fall 2019 moving forward. They don't even have a data set for fall 2020 because it was such a wacky year. So it's just a cautionary on that. While we do have access to it, I'm not just going to say, hey, SACSIM is inferior or anything. And we are working towards kind of building towards that. It's just having access to that data points is kind of our roadblock. But yes, moving forward, Replica does have work from home and EV capabilities with their recent update up to spring 2023. So I just wanted to chime that in just to ensure the audience is aware of it.
Thank you, Warren. All right. So we've got also Dave wants to share as well, and then we'll keep going around.
Yeah, I just wanted to follow. Should I stay as attendee or join as panelist?
Dave, it's hard to hear you. Maybe move closer to your mic. We'll turn it up in here. Try one more time.
Can you hear me now?
That's a little better.
Okay, sorry. Yeah, I was going to follow up on what Gary was saying. I think you had said kind of transportation projects after Gary's request. I think Gary's talking more, and Gary, correct me if I'm wrong, more about on the project, on the land use project side of things, and a lot of the big greenfield sites. And I think some of the mapping that we saw yesterday from the land use and GIS folks, I think a lot of that kind of mapping online where we can scroll around and query those areas would be really useful. And then another thing that we've been doing a lot of, that I think Kyle's familiar with is, we've been kind of creating our own scripts to replicate your VMT per capita and VMT per employee calcs at more of at a TAZ or a parcel or TAZ level. Obviously, TAZs are more appropriate than parcels, but I think a consistent methodology for doing that, because that's what, that is what the local agencies are looking for SB 743 is location based for projects. Whereas for small projects, we can use the hexagons on the map that is online. I think a lot of what we are looking at is more at the project and TAZ level. And a lot of times it might be TAZs that we have added to the network and split out ourselves. And while, we, and I assume other consulting firms have created scripts to do that kind of work, we just want to be able to confirm and make sure that what we're doing is as consistent as possible with what SACOG has been doing. So
Great.
We're not too far off.
Yeah, thank you. I've added that to our notes, land use and transportation. And yeah, if y'all ever repeating some of those calculations, how do we provide those scripts and have consistency? Okay, great. We're going to keep moving. All right. Anybody else at this table? We have a couple more tables to get through. No.
Oh, I guess I could very quickly mention just some little down in the weeds SACSIM thing that you mentioned this Python wrapper, which really creates a bunch of opportunities to basically do all the good things that Application Manager does without having to use Application Manager.
All right. Sounds good. Okay. At this table, let's get it going. See if you can we pick up speed a little bit? No, you're like, how can I pick up speed when I don't have food? Let's do it. Okay. What you got?
So I've just got one thing. Over the last 2 or 3 weeks, I've had 3 different developers ask what they would have to set the residential density to avoid a significant VMT impact.
Mm-hmm.
So anything quick and dirty that could give us that answer would be awesome.
Residential density to offset or eliminate the VMT analysis?
Yeah, they don't want significant and unavoidable.
Got it. Okay. Anybody else at this table? It's your chance.
Really quick, and more 30,000 feet and more scaring every SACOG employee right now. We're talking about this idea that the context is, I used to work for something called the Global Footprint Network 16 years ago, doing visualizations, GHG stuff. And the second part of the context is today, most of the people we are trying to show the results of the modeling work and SACSIM are eventually trying to sell it to the public. And so Ethan and me were talking about this idea that, some of the tools I have seen in the developer planning space is 3D visualization of the same stuff that the data that you will produce coming out of SACSIM, to see movement of vehicles, to see those vehicles and those streets and those highways next to new developer projects. We want to give more tools, more power to the people who are eventually selling it to the community, So thinking more 30,000 foot long term, what is it that we want to empower people with? So SACSIM does the hard work. Now the
Mhm.
easier work is how do we sell that story?
I appreciate you saying that because I'm on our government and public affairs, which includes our comms team, and we think about this a lot, right? This is science communication, right? And so I really appreciate it. I think that that's a good reminder for us to continue to work internally. We haven't had the kind of government and public affairs team before in SACOG like it is now, kind of as structured as it is. And so I think we have an opportunity to grow together in that. So yeah, thanks for calling it out. All right, let's go around. What do you got? This table. Will you push that button real quick?
In general, first of all, this table is just like RT and SACOG, so we just had like
Great.
a good little collab session. We just generally talked about how RT produces like a wealth of data, ridership data, service data, and how we can take that wealth of data to make it more digestible, because right now it's not necessarily very digestible, both internally for us and for the public as well. So yeah, so that's generally what we talked about. I don't know if Darren added to that.
Great.
Yeah, I think you mostly captured it. Just like, is there opportunities to, like dashboards or ways to kind of see, like, make it more digestible. I think you summed it up pretty nicely.
Awesome. Sounds like another project potentially coming down the line inside your team. Very good. Let's go to this next table. Thank you. Anybody here? No? Okay. She looks like she's very involved in something. That's all good. Anything online? Okay. You did over the study. Sorry. Last table.
Yeah, similar to what she said about PopGen.
Did you turn your mic on? Oh, good. You got it. Okay. Sorry.
Just the buffering process is very tedious a lot of times. So just making it a little bit easier on that sense. And Kyle will give me a little bit of debrief on the next session and what they're going to talk about there. So
great. What else?
I would also note there's more housing related tools. There's a lot of state bills that come down in certain buffer areas. So using the PPA tool to have a buffer system with it instead of just line-based tools would be very helpful.
Mm-hmm.
And even just a forward-facing map that marks certain parcels as applicable for certain state bills would be really helpful for developers and the county.
Yeah, I feel like Sac County's hired, or maybe they just hired an infill coordinator. So what kind of, not just that, but that was that spurred that thought in my mind about how can we, how can we help on that housing front? Okay, great. I think maybe we need to rename that. What is it called? The major transit stops. Can we make that look like more TOD? Like, is that what it is? So that's just one idea I had. Anything else at this table?
Yeah, just a final thought that the automated Python script, it would be great if we could have like a region local road safety plan where the TIMS data is pumped in to it and through the pipeline, and then a dashboard's created, and then each district can like draw a circle, and then it creates the high density crash network and all the components of a local road safety plan automatically, instead of cities having in other jurisdictions having to do it every few years.
Wow, that was like, I could sort of see it in my mind. I think maybe let's, yeah, that was a lot. Great. So wait, can I just clarify really quick? So is this the main piece is sort of like this dashboard that kind of aggregates and then you can also pull from it?
Yes, I guess I want to have a tool that's constantly being, that's constantly up to date, but then
Yes.
something that you could pull from and it creates a report in time.
Okay. Thank you.
I see Darren frantically taking notes on this one as well.
We'll follow up, right? This
yeah.
isn't our last conversation.
I have one to add that
Yeah.
I heard from Gary previously is, I think on our VMT maps, having some transparency to be able to see what's under them.
Good. Sorry.
Hopefully that's low hanging fruit.
Yeah, I was going to say VMT map transparency. You're never sure which kind of transparency we're talking about. No, yeah. No, I got it. I actually have a degree in geography, so I am familiar with GIS, I promise. I appreciate that. Any other clarifications, other ideas, anything that sparked? No? Okay, it's time to refuel and relax a little bit. We'll come back. And if anything else comes up, please, grab me, grab Kyle, and or grab Darren, anybody kind of just put a bug in our ear about what you want to see. Thank you. We are going to go to lunch. We are coming back right at noon. It's 12:59. So we did great on time. Good job, everyone. So come back here at noon. Patio is hopefully maybe a little bit cooler today. I'm not sure. But enjoy lunch again. Thank you. All right. We'll go ahead and get warmed up here, get things going. Oh, okay. Thank you for being here, staying all afternoon. It's wonderful. Let's review what we have coming up this afternoon. So first, we're going to hear updates on SACSIM technical enhancements. That's Eason. He's coming in right now. We'll hear from Darren on transit updates. We'll have a SACSIM user community presentation from one of our guest presenters on unlocking SACSIM. This is a applied use case, yes, or just sort of deeper dive in using it. And then we'll hear about the our new tool introducing region. It's a population synthesis and forecasting tool. And then we'll get a summary of SACSIM 23 release information and timeline on that. So that's what we've got on tap. So I would love to pass it over to Kyle to introduce Eason.
Hi again. Just a quick introduction to kind of set the frame with what we're looking at. So if you were looking for details that we were not providing the rest of the conference, this is the session. You're here. You stayed till the end. So congratulations. You're going to get some weedy details. So Eason's got actually 3 topics here. The first being the traffic analysis zones update. Second being our free flow speed update, and the last but not least, the DAYSIM calibration and improvements. These are all really major impactful development pieces of SACSIM. We've received comments from past user conference. The traffic analysis zones, for example, are not necessarily refined enough to really capture the demand from specific new developments. So he'll talk a little bit about kind of what we did to essentially revamp that and some of the improvements. Free flow speeds is a large discussion on how does the model use free flow speeds. We known there's room for improvement here, but we didn't know how. And so kind of 2 things that came online. The first I mentioned yesterday is the big data. We have NPN RDS speed data, which we didn't have in the past, and it's quite a larger segmentation of the total roadway network. And then finally staffing. So we got Easton online. He was an intern here for a couple of years, and we're really happy to have him as a full-time analyst here at SACOG. And so we were having someone to do a deep dive, and we're looking for feedback. And then DAYSIM, as I mentioned, kind of the core concept of our model, activity-based model, is estimated based on household travel surveys, but those don't get us all the way there. So we have to do a lot of technical work on our own. I think some of these address some of the questions onto how are we reflecting a new normal? Are we able to make changes in the core modules to reflect things that say the pre-pandemic is one way of people traveling, and how we're doing things in the future? Easton has a few slides on kind of, we don't necessarily have the answers, but we're working on our tools to think through that. So hopefully that kind of provides the context as why we took a deeper dive here. And with that, I will give it off to Easton.
Thank you, Kyle. Thank you, Alex, and thank you everyone for being here. My name is Eason Zhang. I'm a transportation analyst in the modeling team. So during this planning cycle, we have made quite some technical enhancements to the travel demand model, SACSIM. And among many others, I'm going to cover 3 significant parts of them. And they are TZ updates, free flow speed calibration and the DAYSIM improvements. This is outline of this presentation. I'm going to first talk about the TAZ update, covering like why we are doing this update, what are the data sets we utilized for the update, and how the update help us better, how the TAZ structure is better delineated through the update. And following that, I'm going to talk about the free flow speed calibration utilizing the NPM RDS data, which leverages the big data. And I will talk about the challenges we encountered during the calibration process, how we deal with that, and how we evaluate the calibration results. And after that, I'm going to talk about the DAYSIM improvements. DAYSIM is a activity simulation model within SACSIM. And and we have utilized the most recent data to recalibrate the model and add new functionalities to address the planning needs of this planning cycle. And after that, I'm going to answer questions you have. And in between, because the three topics are kind of different in some sense, so I'm going to have a pause for 1 or 2 minutes to answer questions you may have for each of the topic. So first, TAZ updates. So for those of you who may not be familiar with TAZ, TAZ stands for Traffic Analysis Zone. It's the smallest geographic unit used in transportation modeling. Sorry. Used in transportation modeling, and because of the granularity data, when doing transportation modeling, it's way too computationally expensive to model the precise start and end location of a trip, and also that would pose a high requirement for the data to calibrate the model. So we definitely cannot do that. So for most of transportation modeling, the area is divided into smaller geographic units that's called TAZ. And when delineating TAZs, we want to make sure the land use and the demographics within each TAZ are as homogeneous as possible. And in that way, we can model the trips to and from each TAZ as a unit. And because of that, so the principle for TAZ delineation is to make sure the TAZ structure is delineated to reflect the land use, the census data, and the various boundaries, including both natural geographical boundaries and man-made boundaries. For natural geographical boundary, I mean like a creek, a river, or a ridge. And for man-made boundaries, I mean like railroads and major roadways. And for TAZ delineation, for this planning cycle, we have utilized, this is a list of the data sets we have utilized for the TAZ updates, including block group boundaries, jurisdiction boundaries, and many others. Among them, I want to highlight the federally recognized tribal lines. And by incorporating this data set, the updated TAZ structure is able to better capture the transportation needs of the people who work and live in the tribal lines, so that we are able to better plan for them. Oh, so just a quick note here. I will talk about each how the TAZ is delineated utilizing those data sets one by one using examples. So on these slides, there are 3 examples that demonstrate that the updated TAZ structure is better aligned with block group boundaries and the jurisdiction boundaries. So in the first example, it's a TAZ located in Northeast Sacramento. And the legacy TAZ, which is called TAZ07, is shown in red. And you can see in the legacy TAZ is not kind of well aligned with group boundaries. And with updated TAZ structure, the TAZ21, you can see it's well aligned. And why it is important to make sure the TAZ boundaries are aligned with block group boundaries? That's because ACS data serve as an important data source for our transportation demand modeling. And block group is the smallest geographic unit of ACS data. And by aligning the TAZ boundary better against the block group boundary, it not only streamlines the subsequent data processing, but also improves the accuracy of the data processing to some extent. And on the right, you can see examples demonstrating the updated TAZ boundaries are better aligned with jurisdiction boundaries like city county boundaries and sphere of inference. And why we are doing that is because by aligning the TAZ boundaries better against those jurisdiction boundaries, we are able to more precisely capture the trips to and from those jurisdictions so that we can better analyze their transportation need. On this slide shows 3 examples that the TAZ boundaries better incorporated the geographic boundaries and man-made boundaries. So if you look at the example in El Gulf, so in the legacy TAZ structure, there was a TAZ. You can see kind of a larger TAZ there. And there is a creek that crosses in the middle that substantially divides the TAZ into 2 sub-areas. And the loading of the traffic from the 2 sub-areas onto the highway network are fundamentally different. And they should be modeled separately. So in the updated TAZ structure, we incorporate that. And there is a similar example in Citrus Heights. I tried to use a satellite map to demonstrate, but the resolution is not too good for you to see that. So yeah, but it's essentially the same example as the one in El Gulf. And for major roadways and railroads, it's basically the same concept as natural geographic boundaries. So it divides the area. And you can see the updated TAZ structure is much better incorporated those boundaries. And here is an example that the updated TAZ structure better incorporates travel lines. So this is an example of the Uchadiki Winter Nation. It's located in the west of the city of Woodland in Yolo County. And that road, that's State Road 16. And there is a creek here. That's a Catchy Creek. Sorry for the pronunciation. Yeah. And you can see the legacy TAZ is delineated mostly following the block group boundary. And on the map, you can see 2 pieces of area of the federally recognized tribal lines. The one on the bottom, that's a casino, that's a major workplace. And the one on the top, the smaller piece, that's a residential place. And in the legacy TAZ structure, the centroid of the TAZ will be kind of up here. And the traffic will be loaded onto the highway network through a central connector that's kind of like 10 miles long. And for example, there is a transit route, YOLO 215, along this route. And when we model the transit ridership for that route, using the legacy TAZ, because people need to walk like 10 miles to get on board of that transit route. So the transit ridership modeling results would be biased downward. But with the updated TAZ structure, we can better capture the trips.
And Easton, if I may, I just want to pause here for just a second and talk about where this came from. I know, some of you all are from our jurisdictions and you may work with some of your tribal partners in your area, tribal governments. We had a data request come in from Yochadihi on a greenhouse gas emissions modeling inventory. And so when Kyle and I looked at it, we said, oh, like some of our areas that are more sparsely populated, right? These TAZs are quite big and they're not very representative. And so, we had a fix for them to kind of figure out, I don't even remember what is it called? What's the technical term? You gave her the not trip tables. I can't remember what it was, but they wanted to be able to capture, doing this GHG inventory in those tribal areas, and so we went back and we gave them data, but then we said internally, what can we do so that moving forward we have these areas better delineated, and so we can even kind of understand what's happening here. Cache Creek, I think, is one of the highest grossing casinos. I think maybe in the state of California, if not in all of Northern California, right? So that draws a lot. We've talked about travel across and in and out of the region. This is a great improvement, and we did it Easton did it for all of there are 5 federally recognized tribes that have lands in the area that show up on this database. But it was a good moment of saying, oh my gosh, this wasn't really even on our radar, right? We hadn't really been paying attention, and we need to pay attention. So thanks, Easton.
Yeah. Thank you very much for the context information, Alex. So I think this is a very good example that demonstrates our effort in addressing equity within SACOG region. And so this is a map showing the updated TAZ structure. I have highlighted the TAZs representing tribal lands. And for the example I mentioned earlier, it's located here. And you can see we have added over 800 more TAZs from the legacy TAZ structure. But as I just showed in the previous few slides, the changes are not just the number. It's better in many different aspects. Okay, so I will pause here for any question regarding the TAZ update.
Any questions? And just from yesterday, someone had a question about the TAZs and if it was moving from sort of stick lines to curve. Hopefully you saw the curve line. This is what we were talking about yesterday. It's got more of those delineations, more granular. Any questions? Let me look online. Anything about this part? Yep, go ahead, Ahmed.
Yeah, this is not a technical question. So when you add more TAZs, especially 800 or more, doesn't that increase the processing time?
The short answer is yes, definitely.
So,
yeah.
So what did you do? I mean, is that something you just have to outlive?
I will defer this to either Darren or Kyle. To my knowledge, have we tried to optimize the modeling process?
Yeah, so I think Easton's right. The short answer is yes. It was actually a big risk of this update was, you can imagine these matrices expanding a lot. We were concerned about that. Surprisingly, it didn't have much of an impact. And what we noticed is when we refined the TAZ structure, we significantly reduced the number of iterations the assignment needed to converge. So I think overall we made performance improvements. And yeah, we really didn't, we saw, Easton's correct, that it did increase runtime, but not significantly.
Oh, interesting. Thanks.
Thank you. Any other questions? Okay. So the next thing I'm going to talk about is a free flow speed calibration. During this planning cycle, we have acquired the NPM RDS data. It leverages the big data and it provides real-time traffic speed on many roadways. And when we have this data, we think, okay, we can utilize that data to for better model development, particularly free flow speed calibration. And the challenge here is the NPM RDS data are encoded in polylines that's like true shape of the roadways. But for our highway network, we represent the roads as a ball stick structure. You can imagine it's node representing locations along the road and a straight link connecting the two nodes to representing that stretch of roadway. And it's really hard. We don't have a direct correspondence between the data and the highway network links. For example, say the 15th street between I street and J street. So say we have the observed data on that link, but in the model, we don't know how to establish the correspondence. So to do that, we conflated the data to the model highway networks through a two-phased process. We first automatically programmatically conflated the data links with model links, utilizing information like the location, the direction of travel of the traffic volume on the link, the types of the roads, the names of the roads. So we use fuzzy. It's a Python package to see the similarity of the road names. And through this automatic process, we are able to conflate around 80% of the data to the model links. But the rest of the 20% we have to conflate them manually. And for the 80% that's automatically conflated, we also rigorously checked to ensure there is no major errors. And the end result is we have conflated over 90% of the freeway and over 41% of the local roads. And here the percentage means the roadway mile length. And after establishing the correspondence between data and the highway network links, the next thing is to think about how to calculate the free flow speed. So say if you have, let's use the 15th street as the example, say you have the observed traffic speed on that link across the day, then what's the free flow speed? So we need to calculate that. And we tested a bunch of different schemes from literature. And the two most variable one are the 85th, 60th percentile speed scheme and the 10 p.m. to 4 a.m. average speed scheme. For the 85th, 60th percentile speed, that means we use the 85th percentile. For freeways, we use the 85th percentile of the observed speed as the free flow speed. And for local roads, we use the 60th percentile to incorporate the delays by traffic controls like stop sign and traffic signals. And for those of you who may not be very familiar with percentile, so let's imagine you have 100 data points and you sort that from highest to lowest. Then the first one, smallest, that would be the first percentile. And when you count up, and the 85th of that, that's the 85th percentile. Same for the 60th percentile. And for 10 p.m. to 4 a.m. average speed scheme, that's we use average speed from 10 p.m. to 4 a.m. That's the period when the traffic can travel more kind of freely on the roads. So we use that as a free flow speed. And all those schemes are evaluated through both volume validation and modeled speed validation. I think most of you would be familiar with volume validation, and it's straightforward. But for speed validation, that's a new technique we developed for model development. So as a demonstration, let's say this is the example I randomly selected. And imagine for the data, so the traffic speed on a stretch of road will be different from across the day from hour to hour. And it will also varies from day to day. So for every roadway link, we will have a average observed speed. And on this chart, is shown as a blue curve. And as I just mentioned, there is a variation. So with the variation, we can, the variance, we can compute the 95% confidence interval. And that's shown as a shade here. And in the chart, you can see the orange colored bar, that's the modeled speed for that link across the day. And if the modeled speed lies within the confidence interval, we say that link for congested speed is validated for that time period. And that's how we evaluate the performance of different schemes of free flow speed calculation. And we found that the 10 p.m. to 4 a.m. average speed, by the way, it's excluding all the trucks, so it's only passenger cars, performs the best. So that's how we calculate the free flow speed for this free flow speed calibration. Oh, okay. So that's for free flow calibration. Any questions so far?
Great. So I'm going to go to you in the room in just 1 second. So I see you, Fernando. You have your hand raised. So we're going to take a question in the room, and then we'll bring you into the panelist section and unmute you in just a moment. So you're second in line. All right, let's go in the room.
Can you provide more details on the calibration validation for what exact periods you looked at? And did you look at any peak hours as well?
No, we look at all the time periods across the day.
Okay, so for volume validation, if you look at peak hours, typically you don't do validation on those locations because you have constrained volumes if you're doing counts. So did you do anything to parse out all of the constrained locations so you have a true demand to demand type comparisons?
Oh, okay, I apologize. So for speed validation, we validate against the all time periods. But for volume validation, we validate for the daily volume.
Thank you.
Thank you. All right, Fernando, you are able to unmute yourself. I'm going to ask you to unmute if you're there. You're going to have to respond on your end. So there should be something popping up on your screen if you're here. Okay. All right. We're not seeing you unmute, so we'll leave you there for just a minute, and maybe it was just an accident, but we'll come back to you in case you figure it out. Any other questions in the room? Yes, go ahead.
So I have maybe I didn't catch it. So what is the data you use to do the speed validation, like the blue line that you're showing? What is data source?
The NPM RD data from the INRIX.
So my question will be, did you use the NPM RD as INRIX data to do your speed calibration, but at the same time you're validating to the same data source?
Yes.
Okay, just want to
Okay.
confirm.
Okay. Yeah.
Yeah.
Any other questions? Okay, great. Fernando, we're going to put you back into the attendee list so we don't accidentally unmute, but if you need to send me a chat, please do let us know. I think I'll lower your hand for now, and if we put it back up, we'll know that you're trying to get a hold of us. All right, go ahead, Ethan.
It's not working. Yeah. Okay, cool. So the next topic I'm going to talk about is DAYSIM improvements. So as I mentioned earlier, DAYSIM is an activity simulation model within SACOG. It models various choices concerning the trip, like the modal choice, when to departure, whether it's carpooling, is driving. So all those detailed information. And you can see it's very important for the accuracy of the modeling results. And during this planning cycle, we have conducted our regional household travel survey back in 2018, and utilized that data set. We updated the DAYSIM, and through this update, the DAYSIM can incorporate changes in demographics and travel behaviors since the last iteration of DAYSIM. And with the data set, we have re-estimated the whole 23 sites of parameters for DAYSIM. Additionally, we have further calibrated the parameters of major choice models within DAYSIM. A quick note here, DAYSIM is consisted of a bunch of choice models. We have further calibrated major choice models based on more recent data from other data sources. And in addition to the recalibration of parameters, we also added new functionalities to the model, including the modeling capacity for TNC trips or ride-hailing trips, like Uber or Lyft. Additionally, we have added modeling capacity for telework. For TNC, the model for TNC within DAYSIM is modeled as a new mode choice with its own designated utility function. So now in SACSIM 23, when you model the mode choice, so other than drive, carpool, transit, walk back, you now also have TNC, either Uber or Lyft. And for dead hiding, a quick note about dead hiding, if you are not familiar. So dead hiding means, for example, if you call for an Uber trip, and the Uber trip is 5 miles, and it may take the driver around 1 to 2 miles to drive to the pickup location. And when the driver drops you off, it may take another, let's say, 1 or 2 miles for the driver to the next pickup location. So all those empty VMTs, that's called dead hiding. And because SACSIM, as I mentioned, we don't model the precise movement of vehicles, so we are not able to directly capture dead hiding. So we capture the impact post modeling. And we assume that 40% of the VMT, the TNC VMT will be dead hiding. And I believe that's from Fair and Peers research. And for telework, here I want to note that within DAYSIM, there are 2 distinct types. So telework is a type of remote working. And within DAYSIM, there are 2 distinct types of remote working, so work at home and telework. So for work at home, work at home means the worker operates either a home-based business or the worker does not have a physical working location. But the worker may undertake a work-related trip. For example, a landscaper may travel to the client's destination for work. And in SACSIM, we, as a simplification, we assume all the work-at-home workers are self-employed workers. And during the modeling process, we will have a variable in the person table to indicate whether the worker is a work-at-home type. And the other type of remote working is the telework. I believe most of you are familiar with that. So that refers to a worker who has an official work location, but chooses to work at home for an entire day or part of the day. And during the modeling process, we will have a variable in the person day table to indicate whether the person teleworked on that day. Oh, by the way, the 2018 regional travel household survey data are available per request, and I will show you the request link a bit later again. Among the DAYSIM calibration parts, I want to highlight this time of day calibration, which is enabled by the by time period volume validation technique we developed this time. And here, so a quick recap on time of day. Time of day means the schedules of the trips a person make throughout the day, like when you departure, when you arrive, and the duration of the trip. That's called time of day. And here I'm using the arrival times as example to demonstrate. And on the slides, you can see the arrival times of trips for different purposes. And in each chart, you can see a blue curve. The blue curve, that's the distribution of arrival times from the survey data. And the red curve, that's showing the distribution of arrival time from DAYSIM. And you can see in the past, well, it's kind of aligned, but there is space for improvement. And with the calibration, we can make sure the arrival times are better aligned with the data. And oops. And the DAYSIM calibration can lead to better volume validation, particularly the time of day validation. here. So you can see for the table, that's the time of day validation table we developed. So you can see the period. That's the time period across the day. For H07, that's the morning peak at 7 a.m. and 07 is 8 a.m. peak, so on and so forth. And we have the volume by time period, the observed data and the model volume, and we validate the model volume against data. You can see there are a bunch of different metrics we use for validation. For simplicity and for conciseness, let's focus on the validation ratio. Validation ratio means the modeled volume divided by the observed data. And if it's at 100%, that means we are modeling the volume perfectly. And if it's above, means we are overestimating. And if it's below, that means we are underestimating. So you can see in the past, SACSIM turned to overestimate the volume during the morning peak and the afternoon peak. And with the time of day calibration, we can have better volume validation by time periods. And here's a summary of the three technical enhancements I just talked about, the TAZ updates. So in the TAZ updates, we make sure the TAZ boundaries are better aligned with block group boundaries and the jurisdiction boundaries like city, county boundaries and the sphere of influence. Also, we make sure the new TAZ structure incorporated boundaries like natural geographical boundaries and man-made boundaries. In addition, during this planning cycle, the TAZ structure better incorporated travel lines. And for free flow speed calibration, we utilized NPM RDS data, and through automatic and rigorous manual work, we recalibrated the free flow speed of the network, and we tested multiple different schemes of calculating the free flow speed from literature, and that's through rigorous validation of both volume and speed. For DAYSIM improvements, with the new regional household travel survey, we updated DAYSIM, including re-estimating all the parameters and further calibration with more recent data. And also, the new by time period validation enables us to evaluate the effect of time of day calibration. And with that, we can better calibrate the model. And that yields better modeling results, as I just demonstrated. And also we added functions for TNC trips and telework. So
great.
So here, that's if you are interested in requesting the household survey data, you can through this link. It follows the same procedure Ibrahim just introduced in the morning. And you can scan the QR code to directly go to the link. Okay, any questions?
Great. Thanks, Jason. We have a question in the chat. Dave says, I assume the TNC mode assumes high prevalence to/from the airport. I feel like the summary Kyle showed before had a very low number of TNC trips compared to what I would have thought. Can you clarify the high prevalence? Is that all in there?
So let me summarize the question. So first, he sees lower TNC trips mode share.
Yeah, I think the assumption is would have seemed higher, but it looks like what we're presenting is that it's lower than what Dave would have thought. And does it include the airport, which would be sort of the assumption on the bulk of the trips?
Yeah, for this part, actually, I would actually defer to Kyle. I know the airport has its separate modular. I wonder if that's incorporated there.
Yeah, I'm not sure particularly about the airport, but I think it would be fair that we might be slightly low on TNCs since the percentage of trips is based on the 2018 household travel survey. So if there's more TNC trips now than then, we may be underestimating that particular mode. But that's something you can calibrate as part of the process that ESIM walked through to reflect if you have additional information in your forecasts. John, I see you have a.
Yeah, I might mention that the airport mode choice, travel choices model was based on a 2000 survey, and I don't think it has been updated since then, since around 2008, 2006, when it was applied in SACSIM.
Thank you. So that sounds like to me that there may be a bit of a lag on the current data in terms of what we have. That module needs to be updated is what Kyle just said to me. So you heard it here first. All right, let's see. I've got another, okay, a couple hands. I'm going to take one more question that just came in on the chat, and then I see you. Hi, Jimmy, thanks. Is telework a global input parameter? Does a remote work percentage apply to all jobs, or are there differences by job category?
So telework is a global parameter, but it's the actual telework rate is actually determined within DAYSIM utilizing various variables, and job category is one of them. I can confirm that, and that also utilize things like auto ownership and income levels, among many others. Yeah.
Got it. Thank you. And then you had a question?
Yeah, I wanted to verify your response, I think, to Yo-Yo's question about the NPRDS data, that you actually use it as your calibration data and your validation data. Normally, we use an independent data set for validation. Has that been done?
Yes, the short answer is yes, but I don't see any problem here. So, for example, say the street outside of this building, we have the observed speed across the day. And with the observed data, we can estimate what's the free flow speed, what's the speed that the drivers feel happy to drive freely on that street. And we also have the speed, the observed speed by across the time of day, and we can compare the model speed against the observed speed. That's a validation process. So yeah,
So you are doing it by time of day in that case. So you are able to differentiate between those nighttime speeds versus somebody at 7 a.m.
Yeah, I think I see your question now. So for free flow speed, there is only one single parameter for each roadway. That's a free flow speed, and the model speed can be different across the day, and they are validated.
Okay. And then the next question, I think you answered my previous question that your volume validation was daily with regards to when you were doing the speed calibration. But in your time of day validation, you were looking at it by hour. Is that correct?
Yeah, that's a good question. We do have the time of day by time period volume validation, but for the speed calibration is used as a reference.
Okay. Yeah. So in that peak hour validation in particular, where you are seeing demand volumes higher than your counts, that would be to be expected on constrained locations where you've got queuing and, not all the demand is being served. Have you done anything to break those locations out separately from free flow conditions?
So not really during this planning cycle, but I think that's a great suggestion. I may defer to Darren for any ideas we want to incorporate that. Okay.
Can you, will you just put it on the mic? Okay.
I think it's a good test that we can do. So we have broken up particular segments. So we've looked at, Cap City Freeway being a great example of really high congestion, and compared that with a less congested location. I should mention we did this in levels. So first and foremost, we validate based on our CTC guidelines and everything, the regional level of based on daily ADT traffic counts. But we wanted to do a deeper dive in that. And so we looked at where we had traffic counts. Now it's a smaller set of traffic counts to validate at the hourly levels. And then as we got a much more robust speed data set, we started using that to do an additional check. I mean, you could call it a reasonableness check, but we really used it for calibration purposes. So we were able to adjust those time of day factors of when the trips are departing and arriving based on our understanding. And then kind of to your question, we use the NPNRDS data set, but one portion was the free flow piece. So we identified what we thought could be a free flow speed, taking a bunch of 5-minute averages really, either parsing out trucks in the evenings when we think that the roadway should reflect a free flow design speed, 85th percentile, or some of the work that others at SACOG have done have looked at 60th percentile for kind of a demand model representation of our arterial street that has a lot of stops. And so we applied that, and then we looked at the results of the congested speeds from the NPNRDS based on those 1 hour intervals to see kind of which one performed the best. So it wasn't kind of a one case scenario, and we were able to parse out, do kind of particular studies. So I think to your point, Ron, we could look at really high demand locations and look at how we validate against those locations and compared to kind of a holistic approach, which is what was shown on Ethan's slide.
Yeah, one thing we noticed is that like in the validation for like the I-80 project, did pretty well on the freeways, didn't do as well on arterials. So there seemed to be a difference there. And then in some of the recent work looking at a combination of big data sources, streetlight, replica, and just even manual traffic counts, we have noticed that the peak hours have moved around, and in places like Roseville and Folsom, seeing things like maybe a peak hour, the 30th highest hour being somewhere around like 3:30 to 4:30 versus 5 to 6. So that time of day distribution seems to have also shifted.
Thank you. I just want to bring some comments in from the chat on here about telework and kind of the global parameter. So needless to say, there are some agencies with well-known telework schedules, such as the state of California, obviously, and those jobs make up a huge percentage of Sacramento Central City commuters. Just an observation about work categories and things like that with known telework policies. All right, any other questions? Kyle.
Thanks. I'll be brief. First of all, thanks, Ethan. Really appreciate it. So you mentioned a lot of the calibration and validation, in particular, some of the DAYSIM calibration. You mentioned telework. So I think the initial telework is reflecting what we said was pre-pandemic. How does that apply? And is it different for some of the forecasting years?
So the difference is, as I mentioned, we have a global set of parameters that controls the telework rate. And for the future years, so first we utilizing multiple data sets, not only the household travel survey, but also ACS data and employer surveys, and among a bunch of them, we utilize the data to say what's the most recent telework rate, and based on the trend, we forecast what's the future telework rate. And well, we are not able to fully predict what the future will be like, but based on the best knowledge, we can give a forecast on the future telework rate, and we calibrate two sets of telework parameters. And for the base year, is used so that the model results are validated for the base year telework rate, and for the future year, we have a different assumption for the telework rate. And for the exact numbers, is currently under review, so we can you will have that information when we adopt the plan, when the model is fully available. Yeah.
Great, thank you. All right, any other questions? No, okay. Thank you. Give Ethan a round of applause. Awesome.
Thank you.
So we are going to take a short break. We're going to take a 5-minute break. Adult attention span, especially after lunch, is only about 45 minutes. We are right on the money. So we're going to take a quick bio break. So refill, walk, or get up and stretch. We'll be back in just about 5 minutes. All right. All right, 2-minute warning. We'll come back in 2 minutes.
All right.
All right, folks, we are going to get started again. We have just a couple more presentations and then we'll wrap up. All right. So we have Darren Conley back up to talk about a SACSIM transit updates. Exciting. All right. If you would take a seat, that would be great. And we'll get started.
All right. Thanks for sticking around through the afternoon of day 2, folks. I'm going to talk about some of the transit updates that are in SACSIM 23. Let's see. Key up. Oh, yeah. Oh, okay. Sorry for repeatedly not being close enough to the microphone. It's especially for the folks that are joining virtually. So key transit updates for SACSIM 23. One is changing some of our assumptions about how transit operates in congested speeds. And then also a new option for representing bus-only lanes. Notable, as it says there, it's still a bit of a work in progress, but the proof of concept shows that it should be a good path going forward. So for updating congested transit speeds assumptions, so this actually was inspired a lot by a repeated request from DKS's John Gibbs, spanning back to I think 2019 when he first mentioned it to me. And so we finally have, and also our methodology for updating it is also thanks, very heavily inspired by some work he has done. So to kind of set the stage for the update on transit speed assumptions, I just want to clarify like transit speed versus travel time. So the link travel time, so the time that it takes for a transit vehicle to traverse a link in the SACSIM network, we set it to be whatever the car travel time is, and then we multiply it by a thing called a time factor. Time factors are there to capture all the stuff that makes transit generally go slower than a private car does. So dwell time, the fact that they're larger vehicles and going to have to lumber through an environment with a little more caution. And then it also, the time factor itself can vary depending on the context. So for example, in a dense urban environment where there's, you know, lots of tight turns, or there's more boardings, the time factor is higher because there's going to be like higher dwell times. Whereas in like a suburban context with fewer boardings, and you know, so forth, it's generally lower. And then like on freeways, we assume transit operates close to car travel speeds because it's not picking anybody up. And an example of what the time factor number could look like, if we assume that a link has a time factor of 2, that means we're assuming that it takes transit twice as long to traverse that link as a consequence of all the stuff I just described. This is a pretty good start, but it does have some limitations, at least how we had been using it. So the time factor that is constant regardless of congestion. So, but the challenge is that as a roadway becomes more congested, the travel time difference between a bus and cars is less. So for example, if there's a Watt Avenue at you know, late at night and a bus has to stop, but cars can just go flying by at 35, 45 miles an hour, the travel time distance, or the travel time difference between a bus and a car is going to be greater than if, for example, you're on J Street at 5 in the afternoon and cars are going barely any faster than the bus anyway. And so how do we try to reconcile this? And the effect of this is it also gives transit kind of a short shrift. It makes transit look worse than it really is during congested conditions. And so to address this, you know, with inspiration again from John Gibb at DKS, we adjusted the transit to be sort of a hybrid of congested and free flow speeds. And what that hybrid sort of looks like is focusing on that formula at the top. Basically, or originally, we started by just saying that transit is a function of the congested travel time. But the new formula is that we say the new base speed, instead of being the congested auto speed, we weight it 65% towards the congested auto speed and 35% toward the free flow speed. DKS specifically, I believe they were using 50-50. We tested that, and we think that that's honestly a reasonable one to use, but we did find that if we look at this chart on the right-hand side, this sort of compares the 3 different ways of approaching speed. So the orange line represents the congested auto travel time. So we can see here that as the congested speed gets slower with respect to the free flow speed, that the auto travel time gets slower, right? So if the congested speed is 10% of the free flow speed, then it takes 10 times as long for a car to travel a given distance. If we have now, this blue line represents the transit travel time using our previous method, which is just basing the transit travel time on the congested speed. And you notice that it consistently takes twice as long as the car, which makes sense for a time factor of 2. This gray line represents the new hybrid approach, in which basically as the car speed becomes more congested, the car and the transit speed end up converging. And there's actually a point at which at the slowest speeds, this is actually making transit look a little bit faster than cars, which my own judgment is that I can't envision in the absence of transit only lanes, it doesn't quite seem fully reasonable to have transit go faster than cars. And so one of the things with using like that, that's where this convergence point happens is dependent on these 2 variables, the 65 and the 35. And we found that if we slant it toward 50, that this convergence point happens sooner. And the 0.65 is sort of a sweet spot we found. It's not a magic number. It's just one that seems most reasonable to us and like a nice compromise. So yeah, and we think that this is overall an improvement compared to just using the congested auto speed. We did do a test, and these are some of the results of shifting to the hybrid. So the results generally are in the correct direction, and I would in terms of magnitude, I would expect them to be small, but we do see that person hours of travel fell, which would make sense because if transit's going a little bit faster in congested conditions, you would expect person hours to fall a tiny bit. Transit daily service hours dropped again a tiny bit. These are because remember, this effect only really applies on roads that are in really congested conditions. It's not like across the board and at all times. There was a modest increase in regional transit boardings and a modest decrease in VMT, which speak to this change making transit look marginally more appealing. And just these results seem fairly reasonable, and we like to think that this is an improvement and that we're not giving as short of a shrift to transit as we previously were. The second topic is bus-only lanes. Debating whether to answer questions separate. I think I'll take all questions at the end. So for bus-only lanes, now I guess to give some context, just the idea about bus-only lanes is they allow buses to bypass congested traffic conditions, being able to have greater reliability and greater transit speeds during peak periods. Now, there's a couple of traditional ways that we've captured bus-only lanes in SACSIM. One of the ways that we've done it is adjusting time factors. So for example, using, as shown in the diagram here, the green portion would represent where we have bus-only lanes. And we would say, well, if normally under urban conditions, this route has a time factor of 2, i.e. it takes twice as long as a car to go along this segment. Well, within these bus-only lanes, speed it up. So we say the time factor is like only 1.6. So it takes, 20% less travel time because of the bus-only lanes. And this is a good start. It does capture, the idea of a bus lane and improving transit speeds. But it is very coarse. It is somewhat judgment-based. Like, how do you assume, if you could do maybe literature review or case studies, but coming up with whether it's 20% faster or 30% or 40%, it can be a little challenging to just kind of come up with a number on that. And it's also very hard because you have to coordinate it with road network changes. So if you say a bus for this segment if you're going to put in a bus only lane here, you have to make sure that you not only update the transit line file to represent a lower time factor for those segments, you also have to make sure that you're updating the highway network, especially if your transit project is removing a travel lane. You have to make sure you update the highway network to remove that travel lane, and it creates sort of a data management headache, especially if you have a lot of different proposed bus-only segments in the region. Another option we've traditionally considered for bus-only lanes, depending on the nature of them, is to have dedicated separate transit links in the model. This is how we currently model light rail, and this would only be used for like completely separated BRT. So like LA's Orange Line, for example, where it's completely separate from traffic, or with the exception of signalized intersections. But this is another way you can capture. You just have transit run on its own links, and they have their own set speed. You don't worry about setting a time factor higher or lower. But again, there's a couple issues with this. One is that it assumes that bus-only lanes are completely unaffected by car traffic, which in some cases is an appropriate assumption, but in a lot of cases, there is friction from having cars nearby, and you have cars sometimes turning right across it or turning left across it. So it's generally, in a lot of cases, it's not fully appropriate to assume that a bus lane is completely unaffected by car traffic. And similar to the previous option, you do need to make sure to coordinate bus-only lanes with road changes. So if you have a bus rapid transit project that's proposing to repurpose a general purpose lane, as a modeler, you have to be very conscientious and ensure that you're not only adding the new link for buses, but you're editing the road link to remove that car capacity and to keep all that sort of straight from a data management standpoint. So this brings to sort of a new option, or at least new for us. Please, if anybody in the room has done something like this before, I'd be happy to know. But basically, we add a new road network attribute. It's called a bus lane tag, and it's one that we feel is really a good option for on-street bus only lanes. So if we set we set it so that if this bus lane tag equals 1, then you would weight the transit speed 85% towards the free flow car speed. So similarly, it's like the hybrid speed I just showed, but instead of weighting mostly toward the congested speed, you're weighting it mostly toward the free flow speed, on the understanding that even during congested periods, buses will operate almost as if it's uncongested travel times. And of course, this 85%, you could modify it based on project specific knowledge. So if you feel like it's going to be more segregated from cars, you could set it to 90 or 95%. Or if you feel like there's going to be a lot of intrusion from people like holding the bus up by turning right, then you might dial it down to like a smaller number. And so one of the advantages to this is that you don't need to touch any time factors. And you can also write model scripts such that based on the bus lane value, you can have it accommodate a bus lane either by not changing the general purpose lanes, like if assuming you're widening the road to build a bus lane, or if you set the bus lane number to a different value, you can say, well, if the bus lane, for example, equals 2, weight it 85%, but also chop out a general purpose lane so that it just from a data management standpoint, you can build in the data so that you don't have to in separate steps keep track of how your bus lane is affecting general purpose lanes. And here's an example in the diagram showing that outside of the bus lane extents, the bus speed is weighted 35% toward free flow speed, like I was showing earlier. And then within the extent, it's weighted 85% toward the free flow speed. I did do one test with a very hypothetical, not in any form of planning stage project, where along Watt Avenue on the northern half, I set the bus lane tag so that it converted an existing general purpose lane to a bus lane, and then on the southern half it had a new bus lane, but it was created by widening the road to add a bus lane as opposed to repurposing an existing lane. And two things I looked at, this is sort of gut level reasonableness checks, were how did this affect assignment? And we can see here that in this on the left hand side, that areas in red are where the car volume and capacity ratio increased. So congestion got worse. And we can see in the northern half that that definitely happened because there's less capacity. So the congestion got worse. And we also see that traffic volumes and congestion got worse on parallel routes. As you can imagine, congestion on Watt worsens. So some trips shift to alternative routes. And then similarly, in the southern half, where the bus lane was accommodated by just widening the road and not taking out any general purpose capacity, that it was the opposite. The volume over capacity ratio improved, and some traffic started assigning on to Watt Avenue because it was a comparatively faster route. So that's sort of a gut level check of like, okay, did the lane changes get captured, and did they reassign traffic in a way that at a gut level makes sense? The other side we looked at is like, well, did these bus only lanes have the expected reduction in transit service hours, right? We would expect that if we're weighting the bus travel speed mostly toward the free flow car speed, that we would expect to see transit vehicles go faster, and therefore, if you're holding frequency constant, that would equate to a reduction in revenue hours. which we did see. We see like these are all transit routes that at least in part use the corridor that had bus only lanes added to it, and they all saw a reduction. One thing to note for the folks in this room that work at transit agencies, revenue hours literally just means the time the bus is actually serving stops, and it does not include, for example, lit time for like layovers or anything like that. But this does kind of show at a reasonableness level that this is to me, these are expected outcomes for improving transit speeds along this corridor. And I think I went through some of these advantages already. The potential for easier data management, so you can automatically update road network lane counts based on the bus lane value instead of having to remember to couple changes to the road network and the bus lane tag. There's also a lot of flexibility and customizability. So like you can, let me see, what did I put as an example? Bus lane values correspond to different actions on the road network. I can't remember that one exactly. The third bullet point is it's also can be, there's potential for it to be useful for doing transit priority area legislative analysis. So one thing that is still in a bit of flux for us is the definition of a major transit stop being a BRT stop. In some definitions, it would be any stop along a route that is at least, that it has at least 50% of the route in dedicated bus lanes. It's potentially, there's a definition where it would be, it's only stops on the portion of the bus route with dedicated lanes. And if it's that latter definition, then having that bus lane tag coded in the network is a really nice a really nice attribute driven way to kind of flag where bus only lanes are. Next steps of bus lane development. Like I said, right, we've been using it in some experimental versions of the SACSIM script, but we do want to make it a part of just the standard SACSIM 23 run script. And we've also been kicking around some ideas for how to make it time of day. So if there's like a peak hour, if there's bus lanes that are only bus only lanes during the peak hour, can we specify those to happen only during those peaks, and then they serve as extra general purpose lanes during the off peak? So, oh, that's it. So,
Great. Thanks, Darian. Very interesting. All right. Questions, comments? Yes, James. Press it and it'll turn green.
Green is good.
Yes.
Oh. Yeah, thanks, Darren. Yeah, if I'm reading it right on Watt Avenue, it was like 3 hours on Route 84. Like A is inbound, B is outbound.
yeah, that would be about right.
Yeah, I mean, that seems plausible. Like, I'm a big believer in benchmarking these things. I think that works out to about 3 minutes per trip, about a 10% savings on that segment.
Yeah, like this is across the whole day, so in the aggregate, and yeah, I mean it's a good idea to take that like sort of gut level check, is like, does this seem way too low or way too high? But yeah, it doesn't seem obviously off. At least that was my judgment of it.
Yeah, that facially seems pretty good. The kind of earlier in your presentation, you mentioned that like as congestion increases, transit becomes more competitive. And yeah, that may be true, but if it is, it's counter to like 100% of the anecdotal accounts I've ever gotten from a transit customer, bus driver, or road supervisor. And they may kind of have tunnel vision on it, right? They just see that it's worse for them and not that it's comparatively worse for other motorists. But I would challenge you to, instead of poke holes, hypothesize why or how that could actually be credible. I mean, the anecdote that always comes to mind to me is, you know, the potential customer we want lives out in Natomas, is trying to get to Sac State. And the city is doing a road diet on the bus route that would get them there on Northgate. And they look today and see it would take like 2 hours in a connection to get to Sac State. And the road diet's gonna make it take 2:10, 2:15. And they're not comparing to driving on Northgate and El Camino and all this, or San Juan. They're comparing to driving on the freeway. Nothing's happening on the freeway. So yeah.
I can address that somewhat. So I think the better so you were framing it as more congestion makes transit more competitive. I would say that I would rephrase it and not use the word competitive, but it's just sort of an objective reduction in for the segment that's congested. There's just a smaller difference in the speed of driving versus on transit. It doesn't mean transit's going to be good, right? Transit's still going to, like a road diet on Northgate that makes traffic congestion worse, it's not going to make transit any more appealing. It just means that the difference for that section of Northgate, the speed between transit and driving is going to be a little less. But yeah, I would not market it as something that is going to increase transit ridership. And in terms of showing those, like the improvements back here in the model, like, don't think of this more as like, oh, wow, we made transit better. It's just, we were actually making transit look excessively bad. And we're trying to correct it to make it a little more realistic. I think that's a better way to think of it.
Yeah, no, I appreciate you making that distinction. Because yeah, I mean, pedestrians are our customers too. So road diets make their lives safer. So we like that for safety. But I feel like our partners in local DOTs are often arguing with us that the road diet is also going to make transit more attractive. You know, I can't say I'm particularly convinced of that.
Right. Separate conversation.
Yeah.
Thank you, James. Obviously, when everybody's moving slow, everyone's moving slow, right? Good points that we were talking earlier about communicating, right? Some of the science, I think that's a key part of it, right? Like how are we very intentional about what we think this means? What does the data sort of show and then the data that's from the street, right? That says what's going on. I was whispering to Kyle about when I bike home on 21st and it's trafficy and not for me. My bike lane is free, but me and the bus, which sometimes I take, we're like lapping each other. And I think like, gosh, you know what, I've made, if it's too hot, I'm going to jump on the bus, but it takes about the same amount of time. So anyway, I was just going through my own anecdotal empirical evidence. Other questions? Yes.
Yes, so you said that every link has a time factor for transit, and well, the links have different lengths.
Would you be able to turn on the mic?
It is on.
Oh, it is on.
It was just not so close.
Could you repeat the question?
So every link has a time factor for the transit, and links have different lengths. So the question is that for determining the time factor, was there any supportive empirical data, or was it just assumptions based on the congestion levels of that link? And also, we looked at exclusive bus lanes. How long are such lanes in the SAC area?
So to answer your first question, me? Okay. So to answer your first question about how the time factors were developed, they could probably stand to use an update, but I believe they were developed quite a while ago using a Google API that would compare the travel time from one end of a bus route to another versus driving those same routes and it is using those two travel times. So if it took 80 minutes to take a bus and then 40 minutes to drive it, right, that would be a time factor of 2. But a lot of them were developed before I started working at SACOG, and we've been generally copying or repurposing some of them based on the presumed operating conditions. So like suburban areas like Roseville or Folsom south of 50, it's more like 1.5 to 1.6 times. And then urban areas, it's a higher one because it's a greater difference. But yeah, they were developed quite a while ago and they could probably stand to be updating. To your second question about how long some of the bus only lanes are, this region does not currently have any utilized bus only lanes. We do have one section of bus only lane along Watt Avenue over 50, but for a variety of reasons, it's not currently getting used. And we do have a proposed, a planned bus only lane along part of Stockton Boulevard, which I would guesstimate to be maybe 2 miles or so. And then the one I showed in the example, that was purely hypothetical, and that's not a planned project.
Thank you for the question. Anyone else? Yes, go ahead.
So I'm curious about whether the congested transit speed is applied to all types of transit facilities. So think about if we have a development project, then the applicant is proposed community level shuttle bus. I'm just curious about how the applicant may use this new function to better represent their project, or it could be also overly used to reduce the VMT of the project.
For neighborhood shuttles, assuming it's like a fixed route shuttle, because SACSIM does not at this time model like demand response services, but it would receive, as of now, we would probably give it a time factor that's comparable to other routes operating in the same environment or in a similar kind of built environment. But other than that, we wouldn't make any special assumptions about it.
Great, thank you. Other thoughts or comments? Wrap up this one. Yeah, go ahead, James.
Yeah, and I probably posed this one to you before, Darren, but is there any way, or have you guys conceived of any way to kind of represent the visibility of a service that I think more on rail than bus, but the example I always think of is like the Folsom line in the East Sacramento corridor, which was built in US 50 right away because it was available and inexpensive, but is basically lines up with the loading docks of Trader Joe's and Save Marts and all these beautiful restaurants. And had it been built 150 feet north in the median of Folsom Boulevard, I think would have completely transformed the character of that neighborhood over multiple generations. And in the model, it would have shown up as slower than it is today, which all other things being equal would be worse ridership. But to me, it's conceivable that it could be a much more today we don't get a lot of ridership at 39th Street, 48th. These are pretty much dead stations. I got to think if those were right on that Folsom Boulevard corridor, those would be hot stations. People would love going there for nightlife, meeting, all of that.
Well, I think it depends on how it's captured. So for example, you're talking about the Gold Line, right? Yeah. So like the Gold Line is a light rail line. And if it was operationally going down the median of Folsom, we could probably realistically treat it like a BRT where it's like 85% weighted toward car speed. So yeah, it might be a little slower than where it is right now because it doesn't have as much cross traffic to deal with. The flip side, and so that might make it less attractive. The flip side of it, though, and kind of speaking to your thoughts on it maybe being more attractive, is that our model does capture the coarsely, but it does capture the walk time to get to transit. And so you would have more people within a short walk distance than its current location, and you'd have a bigger rider shed. And so I think that would sort of counterbalance the slower speeds. it's an interesting experiment. I don't know if I can't say right off the top if it would show more or less ridership, but I think the greater accessibility to potential riders would counterbalance the slower speed.
Yeah, it would be really interesting to me if, yeah, that walk distance, if there was like a curve or a gradation to reflect that front door to a major hospital or a restaurant is vastly better than 200 feet away. I mean, being south of Folsom Boulevard on 50 corridor within, if it's like a half-mile buffer, that actually gets you a lot of residents like in Elmhurst and North Tahoe Park that you might not get if it was farther north on Folsom Boulevard. You probably get the same retail and jobs access either way within like a quarter mile. And the residences north of there, it's pretty high income. Like I don't think super high demand, but being, yeah, 25 feet from storefronts or 50 feet rather than 200 feet and on the wrong side. To me, that's very meaningful as just someone who's someone who's worked in transit for 20 years.
Right.
Yeah, if you can make that appear in the numbers, like, I think that could, you know, generate better results for projects and forecasts and stuff, but, you know, I don't know.
No, it's a great, it's a
work cut out for you.
very valid very good observation to make. Yeah.
Yeah, thank you. Maybe like how we used to build streetcars, like right, two people, and then we took them out. It is an old streetcar suburbs. Great comments, really. And for me, you know, I'm not on the data and modeling team, but I think a lot about when we again communicate information and we put it in context. These are some of the questions I think that our team can look back and say like, okay, right, like what if we run these questions? What do they look like, right? So we can kind of figure out, well, how can that data be used? Is it going to show some of these questions? Is it going to make logical sense? What are those gut checks and the gap between the gut check of reality and what a model can do, right? There's always gaps. How do we narrow those in a reasonable and methodical way?
Yeah, I think one other thing too is there, you know, certain elements that are going to be very hard to do a good job capturing in a region-oriented model like SACSIM, but you know, other more like granular tools like dedicated accessibility software like Cube Access or Conveil or something like that, they have a much more granular street network and are much more sensitive to those smaller differences of like you know, having to walk 20 feet versus a couple hundred feet. So there, and that's not going to give you a travel demand estimate, but it can show like, oh, you are measurably improving access to places by putting it closer to a transit stop.
Thanks, Darren. All right, let's give him a round of applause. Very good. Good questions. Appreciate that. So we took our break a little bit earlier, so we're gonna sort of see how the rest of the afternoon goes. We might need to take a little break, but right now we are going to go into our SACSIM user community presentation, unlocking SACSIM. So we have and forgive me if I pronounce your name wrong. You can introduce yourself in just a second. But Adrita is here. Adrita Islam. Oh, here. Okay, great. She is online though. Yes.
Yes. Hello, I'm here. Can you all hear me?
Yes. Great.
Okay.
We can. And you're gonna run slides, Adrita? Yes.
I can run slides and then we can like split it evenly. So I
Great.
will talk for the first part and Drita will talk for the second
Perfect.
part.
You know what you're doing. I'm gonna shut up. All right, go for it.
No problem. Thank you. Can we change the presentation slides? I think. Thank you.
While we get those up, just introduce yourself again. Yes, thank
Sure.
you.
So hi everyone, this is Yo-Yo Zong from Firm Peers. I will be talking about using SACSIM from a user perspective. And then I have here Drita joining us online. We'll be also presenting for this section. So thank you a lot for all of the presentation we had starting from yesterday and today. We know a lot of new things that SACSIM is giving us. And then for this slides, we are more focusing on from like a consulting perspective, how we have been using SACSIM for our projects and then the different technical details we want to kind of like cover on questions you want to ask, how to ask the right question, and then how to find the correct answer using SACSIM. And then Adrita, you can introduce yourself here, and then I can go forward to the presentation part.
Hi, everyone. I hope you all can hear me okay. I'm Adrita Islam. I've been with Burn Pierce since 2018, and I've been using SACSIM since 2018. So I've been through 2 different iterations of SACSIM. This is the 3rd one, and super excited to be here and kind of present on some of the things that we try to look for when applying SACSIM for project applications. Thanks, Yo-Yo.
Sure. Okay, so the framework of this presentation will really be focusing on 6 different questions that we always ask ourselves when we're using SACSIM for project applications. We will go through each of them in the slides. So before we dive into that, I think one thing I do want to kind of emphasize, we kind of like covered this today already. So yesterday, Kyle gives a explanation of what SACSIM is, which covers mostly the right side of the flow of the DAYSIM and the person trip choice model and the trip assignment model that you always use. At the same time, we need to understand we also have 3 sub-model in SACSIM that talks about the airport passenger trips, the commercial vehicle trips, and also external trips. So when you're applying SACSIM for your project, if you have a project, for example, a big industrial project that you have an expectation of change of commercial vehicle trip distribution, then these are some sub-models you also need to take into consideration in your update when you're applying this model. So coming into the questions that we want to ask and then the different type of ways that we try to explain or solve those questions. So first one is whenever we, as a consulting, we have a project come to us, we always first determine what is the scope of this project. Is SACSIM the right tool for us to use for our project? So taking an example, comparing you have a SQL project or you have an operational analysis project, or you're actually working on a project for Caltrans like a highway capacity project. They all change your answer of if this is the right tool for you to use. And then I can give an example of, so for example, you have a mixed use project in City of Davis. Will you use SACSIM to get results such as forecasting your future turning movement volume, doing your level service analysis? So in that case, one of the things we kind of compare over here is the network details in City of Davis between the Davis model and SACSIM. I know with the new TASIS fleet, you should have more granular details in Davis area for sure, but just based on what we have now, comparing to a SACSIM 19, you can see Davis model definitely has more network details. And then if you look at the land use, it also has more land use details in the area. So maybe that can be a better tool for you to use for turn movement forecast, for example. However, what if your project also need to do VMT analysis? You want to avoid any truncation of trips at your gateways. In that case, maybe SACSIM is a better tool because you have the post-processing for your VMT, so you have to take into account additional travel distance that going through your gateways. So there's always different questions you want to ask before you apply this model for your project. And then the next one we want to discuss is how to adequately scope your analysis. Before you do your project, we have to understand SACSIM is a regional model that is developed for the 6-county scale. So all of the validation calibration are mainly done for the freeway locations and maybe some major arterials in the region. However, if you are doing analysis for like say a small project in city of Sacramento, then you should do your sub-area validation to make sure that the regional model can actually be applied for your project. And then when you are actually scoping your analysis, do you do a full model run or segment only run? And then what kind of output should you be processing? So those are questions that we want to discuss. So giving an example of a sub-area static validation. So on the left-hand side of the table, we basically take the off-the-shelf SACSIM model and then compare the volume based on the counts that were collected in city of Elk Grove for 70 locations, including some PAMS locations on the freeway. So as you can see, the model doesn't pass all of the validation results, which makes sense because the model is not calibrated to this detail level of Elk Grove or city of Elk Grove. However, when we are using this model for the Elk Grove general plan update, we will need to do our own static calibration validation, make sure that the model will be suitable to be used for your project. So you have more confidence that the model will produce reasonable results to do your forecast. Okay, the next example is how to right-sizing your model run type. This is example of showing how the volume will change when you are doing a highway widening project. If you're doing just assignment only run or if you're doing a full model run. As you can see, the full model run take into account of the change of person choice. So you see a much bigger difference in the volume. So in that case, you need to identify, okay, my project is doing like an opening year analysis. I don't really expect any change of people's choice because of this capacity change of highway. In that case, assignment only run might be the better choice for you to do the analysis. So you have the tool, but you need to know that how to use this tool to answer your question. So next one is example of when you are doing your analysis. This is example of the output for VMT. Should you be looking at the VMT for a regional average, a regional total, which is like the SACOG region? Or should you do the analysis for like a study area based on your location of the study and the type of study? So this basically shows you if you're doing the analysis for study area comparing to a model wide, they're actually telling you two different stories. One is telling you everything is better. The other one is telling you you actually make it a little bit worse. So really need to understand what the project type that you are doing the analysis for, and then what is the output you should be getting and what's the boundary of the output you should be clipping from the model to give the results. Okay, so next question I will cover is, does model settings matter? So I think we covered this a little bit today of like convergence parameters and then how different convergence parameters will change your model results. And I think John in the sensitivity test also covered this slightly. So we will give some examples of tests that we have done on our end to show you what's the magnitude of change that you are seeing from those. And then if you have a project, should you just run the model once or should you run multiple times to make sure you have a stable results? So going to the first one, it is a convergence basically testing. So as you can see on the first column, we are doing is just as the original setup, doing the base year full model run, and then the relative gap is set as 0.0002 with a 300 maximum iteration. And on the right-hand side are the additional tests were done. 2 tests were done for the assignment only run, 2 tests were done for full model run. And we use a revised setting of relative gap and maximum iteration to make it run a little bit more, to give the relative gap a little bit more restricted for model to converge, and then to allow more maximum iterations that the model can run for each of the assignment time period. So as you can see, the following numbers are just showing that how many iterations were run for each of the time period. So none of them goes even above, like around 100, that's kind of like the maximum. So meaning that the model will already converge to your relative gap without needing to meet the maximum, going all the way to the maximum iteration, which is good, the model converge. And then we can kind of compare. So if you are using different relative gap, how the result will be different. So if you look at the second and third kind of column of assignment only comparison, when you have a more restricted relative gap, you basically shows a smaller VMT change or model-wide VMT change comparing to the original setting. So this is the way that you try to eliminate some of the randomness from the model that you shouldn't be taken into account by your project. So in this way, we are doing an idling like capacity project. So when you are doing your model, your like TDM strategy, or you are doing your VMT mitigation, you shouldn't be taking into account the additional things that are output from the model that not really should be taken into account or be responsible for your project to be mitigating from. Okay, and the next one we want to discuss is, so if you're doing a model run, is one run enough or should you do multiple runs, and the reason for doing multiple runs. So Kyle also mentioned this yesterday, there is a randomness in the person choice model. So there is a input in the DAYSIM model, which is the random seed, and this random seed basically change the person choice in the DAYSIM model. And then this random seed will basically affect your final VMT results or the other indicators that you're using to do your project analysis. So this is an example that you can do just one run, giving you your result, or the average run from the magnitude, actually the difference is just like 0.01 or 0.1% difference. However, when you translate this to numbers of number of VMT you want to mitigate, then that's a pretty big difference. So depending on your project type, if it's more sensitive to VMT, you might be choosing to do multiple runs instead of one run. So that's what I want to cover on my end, and the data will be covering starting from the buffering process.
Thanks, Yo-Yo. So fun stuff. So the next question I want to answer is, do we need buffering? And for those of us in the room that don't know what is buffering, it is a process within the input preparation process where we are trying to, using the relative distance information between different parcels, we're trying to understand how attractive each parcel is and what should be the attractiveness between land uses. And when do we need buffering? So there are multiple things that go into this buffering process that kind of try to understand that attractiveness of parcels and also a proxy for accessibility. So whenever we're doing any kind of transit project or any kind of, we're adding land use, we do need to go through buffering. And next question becomes like, what happens if we don't do buffering? So if you're not doing buffering for your project, if you're adding a new land use project and you don't do the buffering, what happens is that the parcels around the project doesn't really know that your project is within the proximity of existing parcels. So that's why in order to fully capture the attractiveness of your parcel and also the surrounding parcel, you need to redo the buffering in the model to get to an answer that is more reasonable. So some of the examples are whenever we do any kind of big general plans or even specific plans, we definitely want to do buffering. Anytime we touch land use, basically we do buffering, but even within network, if you're adding a lot of new intersections, if you're adding any transit stops, you should be doing buffering. So this is just a visual representation of when to do buffering, but I'm not sure if it's readable on this slide. And then, like I was saying, anytime we do land use updates, we should be doing buffering. Another question that comes here with the land use process is that, do we need to actually do population synthesis? And the answer, unfortunately, is that yes, because even though it is a very rigorous process, we always try to do population synthesis, go through the population synthesis process when we are doing residential land use project in order to capture the synthetic population better. Next slide. The next thing we wanted to capture was that, do we need to adjust gateways and why would we ever do that? So if we go to the next example slide, so the model has gateways. What are gateways? Gateways are the endpoints in models. Most of the times they're freeways, sometimes there are some local roadways where the model boundary cuts them. So in order to capture some of the nuances of your project, you might want to sometimes update the gateways to match the existing conditions. So here you can see some examples. This is two examples we have from the YOLO-ET model and the Elk Grove General Plan model, where we have modified some gateways that the project that was in close proximity to the project, and that didn't really, the volumes weren't close to the counts or streetlight data that we were collecting. So we updated the volumes to match that in order to capture some of the travel outside the region. So next slide. And finally, we kind of want to touch upon post-processing. So Yo-Yo kind of talked about this, like Whenever you go through a process, this model is a regional model. And if you're trying to apply it to a small location, especially for any kind of turning movements or even sometimes for roadways, we should not be using raw model volumes. So we go through different post-processing, including difference method, sometimes ratio method, to get to a better volume. And then with post-processing comes VMT, obviously. So SACSIM, we can get VMT from SACSIM, and there are, like we all know, a lot of different types of VMT. So if we just go to the next slide. So essentially, we have identified 9 different types of VMT that we can need for different types of projects. And in order to get any of those VMT from SACSIM, and you can get all 9 of them, you need to go through some sort of post-processing. So having a proper understanding of what goes into these VMT and what are the different types of trips and cores in the model, you can answer any of these VMT questions that come up. So I think we went really fast because we didn't want to go over time, and those are the kind of topics we wanted to cover. So I'll open it up for any questions and basically answer any questions you might have about these questions that we presented and kind of tried to answer.
Great job. Thank you both. I love this slide. This is really, really nice visualization. Questions? Comments? Is that a hand over there? Yeah, Darren.
I've done some work where I'm kind of intrigued by the issue of like the gateway problem with projects. Like, if you widen YOLO 80, right? Like it's a lot of the induced demand could come from more Bay Area traffic. And it looks like you updated the gateway volumes. Is that literally just going into like the IXXI files in the model and like just manually updating some of the numbers in there? Because I'm just kind of curious how that.
Yeah, I can answer that. So yes, so as Yo-Yo was showing in her first slide, so SACSIM's external travel is a separate model. So, and the major input for that model is the IXXI file. So you would just be going in and adjusting the IXXI file to adjust the gateways according to your counts if needed.
I can add a little bit for that one. So for the IT project that we have done, we actually did a little bit more than just adjusting the existing gateways. We actually extend the model a little bit further away. So we capture more trips that going through this gateway to have a better representative trip distributions outside of SACOG region, but still have a big impact of the volume going through this gateway into the SACOG region.
Yeah, we actually added like 4 additional gateways for the YOLO 80 project.
Wow. Yeah. It's something I can imagine. I appreciate the answers.
Sure.
Other questions?
I guess we answer all of our questions.
Yeah, wonderful. Give a round of applause. A wonderful job.
Thank you.
Thank you for your hybrid presentation. All right. So we have one more presentation. It's very exciting. One presentation and then kind of what's up for SACSIM 23, that release information. So since we're going to go for about a little bit, maybe a little bit less than another hour, take another quick break, run to the bathroom, come back, 5 minutes, and we'll get started and wrap it up with that. Okay. I'll say that right now.
So,
All right.
I'll give you an.
Okay. Sorry. We're going to get started again. All right. We're going to talk about population synthesis and forecasting, introducing region. Kyle's going to introduce Ibrahim and give a little bit more context in just a second, but I want to say this is going to be our last presentation. It's going to take us to the end of the day. So if you have a question, please just raise your hand, flag me. We'll take questions throughout and hopefully leave a little bit of time at the end too if you're mulling it over. I'm very proud that our communications team had a partnership on this. Ibrahim and Kyle came to us with this tool and they were like, it does all this great stuff, but we're not sure what to call it. So we went through lots of iterations, not too many, but landed on region. We are, I think probably, if you don't love it, just let us know. We're probably not going to change it, but it's really fun to collaborate internally. And if you all have, we have some tool ideas here that we got today. We're always looking for good names. So hopefully it'll make sense to you with region. So Kyle, please.
Yeah, thank you. I think Ibrahim and I had coined it the land use update input tool for quite a while. So we needed some help. So thank you for that. Yeah. So region is definitely the kind of the highlight, exciting part, but I'm here to provide a little bit of kind of background of how we got to this point. I think you all actually today connected some of these dots already, but yesterday we talked a lot about population synthesis. Why is it important? Why do we need it? Today we've heard, and we've heard from past conferences, it's really complicated, it's time consuming. The tool, I think what we heard is has not been updated since 2012 and no longer is working. So we heard all this. We've, over the last 2 years or so, have worked in-house kind of updating our population synthesis process. And so first our look was, well, what's out there? So we in SACSIM 19 we use PopGen. It's an open source tool developed by Mineta, and I believe by ASU is currently maintaining it, sort of. And it uses old forms of Python. It's got problems. It's great for what it does, but it needs to be updated. So we kind of did all right, what else is out there? I think we looked at a variety, narrowed it down to 3. Doppelganger, which was Streetlights, now Replica's open source version. Population Sim, which is developed by RSG, also open source. There's a new version of PopGen, and we kind of did a pros and cons of all of them and ultimately determined to migrate over to Population Sim. So Ibrahim's going to talk in detail kind of some of the technical performance improvements that we have in the new population synthesizer. That does not make the tool any easier. So we wanted to kind of first explain why we switched over to this new process, what's the improvements, and then the second part is understanding that does not address the user's need to simplify the tool for cost and the runtime and other things. We developed what I'm kind of coining as a wrapper of this region for not only just the population synthesis, but also for project level or specific plan level buffering analysis. So we heard from Ajita and Yo-Yo earlier on some of the application of the tool. First of all, should we use buffering? Should we use population synthesizer? I would say absolutely yes. They're very important. I would even go to add to if you do any transit projects, if you want your transit stops captured, you need to rebuffer. So definitely stress that all of those things, you're doing the right thing, checking the inputs and checking your models. So with that, the regen tool kind of rolls all these processes up that we need to do before the model and hopefully provides a interface that you all can use and it will be much more efficient. That being said, we're still in kind of a beta process, so we're hoping to roll it out to all the users and get your feedback over the next couple months. So with that, I will introduce Ibrahim Itani. He's also the man behind most of this conference, so definitely want to thank him for all the organization, everything running smoothly. But he's also been working very diligently on updating our population synthesis. So you're going to hear from him kind of the details and the weeds, and then the new tool and how it's going to be rolled out.
Hi, yeah, thank you, Kyle, for that. I appreciate that. So I'm going to talk to you today about the population synthesis process. We're going to start off with a bit on why we synthesize, the general process, and then talk a bit about forecasting, what we're doing in terms of that. And then we're going to move on to the new tool, region, a new land use updating tool, a much better name. Thanks, Alex and team. And we're going to have some questions. We're going to hold some questions. First off, let's talk about why we need a synthetic population. So on our travel modeling scale, we had to make a decision. There needs to be a decision made on 4-step modeling versus activity-based modeling. 4-step modeling has a lot of advantages. I'm not putting it here as a lighter option to take a dig on it, but it has a lot of advantages. It's a lot simpler to use, but it also doesn't give us all the information we would like to know. In activity-based models, we're able to simulate things at the parcel level. We have families, we have people making trip decisions, having tours, dropping off their kids at school, coming back, going to work. And that helps us understand how they will behave and give us a better idea on how they're performing, especially if you have different types of families, different types of developments, and how that will be reflected in different areas. So what we need to run an activity-based model is a lot of data to prepare our synthetic population and how they're making decisions. And our synthetic population needs to be very reflective of reality. Who lives in our region? Where do they live? How much money do they make? How much money do they have to spend? Are they going to school? Do they work? All of that. And this is where our population synthesis process comes from. Our initial starting point is the microsample data that we get from the census. So the census provides us with samples that they actually, I don't know if any of you have taken the census survey. I've had the census person come to my door one day. And basically they take information about different families living in the region, how representative they are. But it really doesn't tell us exactly where to expect these people to live, and by region where how the splits in terms of income, household size are. That's where we need control totals. Control totals are basically how many people live in this neighborhood. How many of these households are one-person households? How many of these households have a person under 18? For example. And once you have those totals in general, oh, I'm gonna adjust my microphone. I hope that's better. Okay, so once we have those totals figured out, we put them into our synthesizer. Yeah, so once we put them into our synthesizer, what it does is that it takes these two separate inputs. How many people live in a certain area and the characteristics of the people that live in this certain area, and the sample that in this large zone, we have these people living there, and gives us synthetic households and populations. I know it's kind of hard to visualize right now, but we're gonna give a few examples to make it a bit more approachable and for you to ask questions. Also, feel free to ask questions as we go, because this is kind of a longer presentation. And if you have any question or you want to understand more about something, please feel free to stop me. So initially, as Carl mentioned, we started with PopGen 1.1, and we're switching over to population sim. Some of the advantages of population sim is that you can have weighted controls for different variables. We're going to talk a bit about that. You can have multiple control geographies. You can control for things at different levels, at the block group versus the tract. And it runs on Python 3, not Python 2.7. There was a comment earlier that PopGen was using an outdated version of Python. So let's start with the control tables. What does a control table look like? And it's a large table, a bit larger than this. But basically what you need to focus on is that in this block group, this number block group, it has 320 households. 116 of them are of size 1, 58 of them are of size 2, etc. And we do this for several attributes. And we put that into our population synthesizer, and it gives us our synthetic population. And let's take an example of what the synthetic household and population table is. So let's start with a household table. And this is, let's focus on household number 2 for now. It's a 4-person household, has a 42-year-old householder. They make 48K a year. This householder is Asian. They own 3 cars in this household. There are 2 workers and 1 child that attends school. What the population table is basically an expansion on each of these households. And each of these rows are actual individuals that got sampled from the microsample. We're not creating attributes. We're just using the samples in the correct way. We're sampling the right households so that our totals match what the census ACS tables tell us. So let's focus on household number 2. We said it has 4 individuals living in this household. It has a 42-year-old householder, so that's the individual number 1. It has 2 workers and 2 working age individuals. And it has 1 student at school that's not at the university. And we have a 16-year-old that goes to school and a 3-year-old that doesn't. So these 2 tables match because they are actual samples, and they fit within our total controls that we want to maintain. I hope that gave you kind of like an idea of what the sample and synthesized population looks like. So let's go back to population sim and some of the updates that we are implementing and how helpful they've been. So let's look at, I mentioned control geographies, that we're able to control things at multiple geographies. And let's look at the tract that we are currently in. We are right here, I think. And this is downtown Sacramento. And inside the tract, we have different block groups. We have 3 block groups in this particular tract. And as my colleague Ethan mentioned earlier today, our traffic analysis zones fall within the block groups. So you can see we have 4 different traffic analysis zones in this area. And what population sim enables us to do is to control for different variables at different levels. So we control for the number of households and the number of persons at the traffic analysis zone level. So this really helps us make sure that we have the right number of people in the right locations. We control for household size, income and age, person age and person ethnicity at the block group level. We used to do these controls at the tract level, but we saw that there's good enough information at the block group level. So that will enable us to have more accurate results. And we control for the number of workers at the tract level. Now, you might say, Ibrahim, like, why do we still control for workers at the tract level? Why don't you go down to block group for everything? Well, we noticed that in some areas, we didn't have good enough data, and the margins of error were large in the ACS at the block group level for this particular variable. So we kept it at the tract, and that works well for us. And I also want to mention that not all of these variables go in as factors in determining travel behavior. For example, ethnicity is something that we want to match and we want to reflect properly, but it's not a factor that goes in decision-making in our travel model. So let's focus on, I want us to look at how PopGen performed versus population sim. And that's kind of like a big motivation. This is a study we did to figure out whether or not we switch. And I want to focus particularly on household age between 0 and 35. So the number of households with a householder under 35. And tract level error. So we're looking at the number at the error level at the tract. So if we look at PopGen, the 2016 population, you can see here that we have around, so this is an error table. And the closer to 0 you are, the better. And the more around 0 you are, the better. So we have around 100 tracts that had 0 error in terms of number of households under age 35 compared to what the census tables were telling us that category had. And it's generally centered around 0, which is what you want to see. Now, when we ran the 2016 population in PopSim, but added some weights where you can say, oh, I think householder age is important. I want that reflected more properly, or person number or household number. I want to match that 100%. I don't want any error on that. You can give that more importance. And when we did that, you can see that there's a big jump in our zero error tracts. There's a lot of tracts with 0 or -1 error at the tract level, around 200. Now, what happens when we also add our different geographies, the ones we were just talking about? What if we control for this variable, householder age, at the block group level? Do our tract level totals perform better? And turns out they do, and we did that for our 2020 population sim. And this is, I think, it is from an actually generated population, and it's closer to 300 tracts that have 0 error. So you can see the progression, and we really like. It's really nice to have a lot of tracts with 0 or +1 or -1 error. And that's kind of where we saw a lot of benefit. And this is not just for this category. It's a great benefit in many others. And I think household numbers and person numbers really perform well because of the new structure. I think they did well previously, but they perform even better right now. Let's look at control totals. So now that we've established that population sim is performing well and we can use it, how do we get our control totals? How do we get that table? So I did mention ACS, and that goes in. So what we first start with is existing dwelling units. We get a file that I think there was a land use presentation yesterday that talked a bit about how they have their land use inventory, where the dwelling units are going, where the employment is. And we get that file, and basically we apply the occupancy rates from the ACS data at the block group level. We have an approved household number based on the census data. We have our centennial census for year 2020, and we also have approved numbers and counts. And we have the ACS household characteristics. So if you go to those tables, and they give you more information on the split in terms of household size. What is the percentage of households of size 1 in this tract or in this block group on size, age, income, and number of workers? And that gives you your household level controls. Once you have your household level controls, you apply household size, because it needs to track. If you have a lot of one-person households, that will affect the total number of persons you have. And then an approved person number, also from the census and other sources, and the ACS characteristic split for age and ethnicity at the block group level, in this case. And that gives us our person controls. We need both those tables to be able to move forward in the population synthesis process. So before I move on to forecasting, does anybody have any questions or concerns that you want to talk about? Yeah, John.
Yeah, noticed in your chart with the frequency distributions of error, the one with the one that was the best,
yeah,
as far as having the tallest spike,
yes,
also had more outliers.
Yes, you're right. You're right on that. It does have a few more outliers that were around between plus and minus 15. And those outliers, that is something that they mention in their documentation. It is kind of a trade-off. Do you want 100 more households with 0 error, and you get maybe 10 or 15, around 10 households with tracts with 15 or 10 error. But those tracts in general are the much larger tracts. That's where these larger errors fall in. So they're not likely going to fall into a tract that's small. They're likely going to fall in a tract that has a lot of people living in it. A very good observation. Any additional questions? All right, so I'm gonna move forward on the forecasting process. What does it look like? Now, the forecasting process is pretty much the same in terms of synthesis. You have the sample, you have the control total, and they go into the synthesizer, and you get your synthetic households and population. But what changes is your control totals. Now you're controlling for a larger, you want more people living there or fewer people living there. You know that their income is gonna be different. You know their age is gonna be different. That's where we apply our controls. And the control is split into two different parts. The first part is modifying existing controls. So assume a use case where, let's say, we don't build anything. There's no growth. Would the population look different 20 years from now? I'm asking around the room. Yeah, yeah, they'll be older. That's a major thing. We need to consider that there's deaths, there's births, there's an increased life expectancy, and we need to factor those in. And how we do that is that we use the Department of Finance demographic projections unit provides us with county level controls and predictions. And we apply those to be able to get our modified persons. And we do this for age. So as mentioned in the room, we have an aging population. And we do this also for ethnicity. So we know the ethnicities in our region are also changing. Previously, we only did this for age, and we did this at the county, at the region level. Now we're doing it for both age and ethnicity, and at the county level rather than regionally. Yes.
Can I pause you for some questions?
Yes.
Okay, thank you. So we've got two online. So can I ask when when was the latest time that you ran population sim? Currently, it seems to not be under normal maintenance. We tried the Python package in May, and essentially it didn't work.
I think I downloaded, well, the most recent time I ran it was around 4 weeks ago, but it was a version that I downloaded 6-7 months ago.
Okay. And then how do you account for new development that may not be similar to the areas where it is going? Often greenfield sites do not have much in common with the areas where they are proposed.
That is a very good question, and we're going to get to it soon. Yes.
Probably a related question here on the age modification. Glad to see you guys have gone down to the county level. Hopefully you'll talk about your ability to go below county level, especially when we have age qualified developments and we have neighborhoods that have just aged and aren't being replaced with households with kids.
Yeah, I'm glad that you mentioned that. We're going to go through an example about how different counties are behaving differently, and definitely going down to smaller scales is important. And one thing that I'm going to talk a bit about later today is that we're also modeling 55+ communities, because we're seeing a lot of those coming up, and senior facilities separately. So we'll be able to capture those as well. So yeah, I'm going to move forward. We apply those modifications and get the modified existing person controls. And let's take an example of, again, our current block group versus a block group near the Placerville Airport. These are very different areas, and we expect them to look very different in the future. Let's see what the demographic projections, the DOF data told us. It told us, okay, in both cases, the 75+ category is increasing significantly. We have an increase in life expectancy. And this is a category that we added in our controls that wasn't there before in order to capture this change separately. And in the El Dorado County, we have an increase in the 0 to 4 category, but a decrease compared to that in Sacramento County. And existing conditions really affect how these projections are looking like. So the 84% here increase is much more impactful. Increase in the 75+ category is much more impactful in the El Dorado County, having longer life expectancies in areas that already have people that are in that category are affected more. And the 12% increase in the 0 to 4 category in that particular block group did not have a big impact. Even the drop here in the 10% in this category didn't have that big of an impact in Sacramento County. So now that we've adjusted people that already live there or the existing developments, let's look at what the growth is. And that goes to the question that was asked earlier. If we build in new areas, how are we determining the characteristics of the people that are living there? It's likely that if you build a new building, it's not gonna exactly look like every building that's next to it. It will has particular characteristics. And we do that by looking at 3 different items. The community type, is it a corridor, an established community? Is it an agricultural community? What kind of development is going in? Is it a high density development? Is it a low density? Is it a mixed and mixed use, and the county in our 6-county region? Previously, we looked at the first 2. And this time around, we're looking at the 3. And when you mix and match all these categories, you get up to 108 different types of combinations. Now, I want you to think a bit, I want us to talk a bit about 2 different types of developments. Let's consider an established or developed community with a very low density development going online, and it's in Yuba County, versus a corridor or center community with a mixed use development going on in, let's say, downtown Sacramento, in Sacramento. So which development do you think will have larger families living on it? Yeah. So the one that's low density is likely to have a larger size family. And which one do you expect to have more children living on it, or working age individuals? The mixed use one is likely to have a working age individual living on it compared to the one that's in a more rural area or a developing area. And that's what we're going to look at exactly. A developed, established community in Wheatland, which is Wheatland, and we have a very low density detached residential development going in on this parcel, and it's in Yuba County. And we have a corridor community, a center community, a mixed use development in Sacramento County. And these are not actual examples, but for the sake of the presentation. And in terms of household size, you can see that the Sacramento County being in orange and the Yuba County development being in blue. The Sacramento County development has a lot more one-person households, so likely working age individuals. Whereas the Yuba County has a more distributed is more distributed in terms of household size. You might have families living on here more likely. And in terms of age distribution, the working age categories are so 16 to 34. Well, it's not completely exactly working age, but the young adult community has a lot more individuals living there because we expect those one-person households to be reflected in that. So it tracks on multiple levels, and that's how, to answer the question, that's how we differentiate new developments. Even if you're building a very high density development, even if it's in a greenfield area, it will borrow these characteristics based on the 3 different categories that we talked about. So how do we get that into our growth totals that will get added? We follow a very similar process. We borrow existing rates and the existing occupancy rates in the area. It's usually around 95%. We have an approved growth number that we get from our board, and it's worked on in multiple different sources. We have the existing characteristics of developments with a similar type of community type, density, and county, and what growth is actually going in. And that gives us our household characteristics. And once we have our household control totals, we translate that into person control totals by looking at the household sizes, the approved growth number in terms of persons, their characteristics based on the 3 categories we described, and the Department of Finance adjustments to age and ethnicity. We also include that for the growth developments. And that gives us our growth numbers. Once you add these to our modified existing totals, you get your new control totals that are reflective, that should be more reflective of the future. And you can see here, we talked a bit about this. We have somewhat of an aging population. The 65 plus category between now and 2050 is likely gonna have a larger portion of the population. Also, we have an increase in the Hispanic ethnicity in our region, and other attribute changes as well in terms of household size and age, and that kind of thing. I'm gonna pause here to see if there are any questions. Yes.
Go back to the slide where you were showing the last flow chart. You had, right?
This one?
Keep going, one more before that. There you go.
Yeah.
So it shows that your growth in dwelling units is using the existing household characteristics, which includes income. This is one of the issues we've run into in most activity-based models and practical applications, is to afford a house today, and the houses that are being offered for sale require extremely high incomes.
Yes.
And so we're not seeing the same characteristics demographically of those occupants, especially on the income level and the household size level. So in practical applications, we end up looking at, well, what is the price of the house that's going to be offered as a single family unit, and trying to replace what is the default values. Is there anything you guys are doing now to recognize that there is a pretty big disparate forecast about the future with regards to the income and housing cost? Or are you just baking in that existing household in every future scenario?
Yeah, I think that's a great comment, and it is something that we are noticing. It's really hard to say when it comes to income. It's really hard to predict where it's going to go, because if you build in a new neighborhood that's already exists, it's going to be it's likely going to be gentrified. You might have higher incomes living in those areas, and that is something that would be great to have. And what we noticed is that when we included income as part of this prediction, we noticed a few issues where we noticed changes in incomes in certain areas based on the new types of developments, and we weren't sure that is going to be reflective, because as you said, that the households sometimes are more expensive, but the best we have so far is that we apply these changes. We apply the new levels of income based on what the new development is going in and what it looks like, and then we maintain regionally the same income level. So our average income as a region, we adjust it to match our current levels, because we don't have better projections or information on that. But the different areas do change when new developments go in them. I hope that was helpful. But I think that is something to consider in the future. Yes.
Likely stupid question, but if so much of congestion can be attributed in certain freeways, highways to vehicles that are not, or individuals and vehicles who are not residents of a certain region, do you, and if POPGen or regen is eventually such a critical element of something like SACSIM, how do we see individuals who are transitorily moving through regions and trucking, for example?
Yeah, so I think that more than on, I think we'll talk a bit more about that in the general process. But you can imagine that this is just getting a good reflection of the people currently living. The SACSIM process and our travel model is more responsible on calibrating who's going where and those decisions that are being made. The population process is just accurately reflecting the people that are living there. And for example, it might have an effect. So if you have higher income individuals or individuals that have more access to cars, they're going to drive more. If you have individuals that have fewer cars, they're going to use transit more. So it's important to keep track of these things, because they do have an effect on traffic. Yeah, if you build a very high density residential development, usually those types of developments have people that take transit, or have the characteristics of people that take transit. So they're more likely to take transit. So that's where that shows up. I hope that answered your question. Yeah, thank you for that. Okay, so I'm gonna talk about like how, okay, so let's go back. So how does this fall in with our general process? So we generated our population, we got it right, we did everything. And how does it fall in with our general process? So as I mentioned before, we start off with summarized land use files, and that includes the geographies, which block groups fall within which tracts and within which micro sample areas, all of that. And we have our existing units and our growth units and what kind of growth units are going in. And then it goes into a new control generation script that is really gonna help us avoid a lot of errors. And I'm gonna talk a bit more about that. This is a script written in R. The main input to the script is you enter the year. So for SACSIM 23, this is gonna be 2020, 2035, or 2050. And you enter your ACS API key, which you can sign up for online. And what it does, it takes all the land use variables and goes online, grabs the right tables from the census, the 5-year 2020 tables from the census, combines those two, and does everything behind the scenes and gives you ready-made control tables. So it gives you control tables at the block group level, at the tract level, at the TAZ level, all ready to go into population sim in the right format. So that really takes away a lot of the intermediate work that you have to do, and takes away a lot of human error that could happen along the way. And we do this process, as we mentioned earlier today, briefly. We do this separately for senior facilities, dorms, 55 plus communities, and then everybody else. Because some of these earlier communities, we care more about certain attributes. So for the senior facilities, we care more that we're managing the 65 plus category. For the 55 plus communities, they have their rules in California, and we need to make sure that we're following these rules. How many people under the age of 18 can live in that household? Those kinds of things. So we control, we add different weights, and we control for different variables for each of these, and we simulate them separately. And the script generates all the control tables for everything all at once. And surprisingly, it takes maybe 25 minutes. But getting the summarized land use files ready, that's kind of the that's the kind of tough part. And then we go through the process that we just talked about, and that gives us our synthetic households. So the synthetic households that we have right now, at the smallest scale, we have them is the TAZ, right? But we have an activity-based model at the parcel level. So how do we go from TAZ level households to parcel level households? We do that by combining it with employment and land use files, and also transit and a few others. And we go through a process, we call it the allocation process, which is basically deciding where does each of these households go? In which building do they live? In that TAZ they are assigned to. And once we know where they live, we need them to know how close they are to things. Because if they want to make decisions on where they work, whether or not they're going to take transit, they need to know that information. And that's where the buffering process comes in. I think Adrita mentioned it earlier today. It's really important to run the buffering process for people to know how close they are to things, and that affects their decision making, particularly with transit. If you add a new stop and nobody knows it's there, it's unlikely that people will use it. And I'm not going to go into details, don't be afraid. I'm not going to go into a lot of details. I just want to mention that we have a security process where if you're close to a river, you don't see the other side of the river as close because it's hard to get to. So it's not just whatever's close to me in a bird's eye view, it's actually how close how easily can I get there. And again, I want to emphasize the importance of rebuffering when you want to do transit updates. So you do your rebuffering, and then you obtain finally your model RAM files. And that's where it goes into the model, and we do our analysis. As you see here, it's kind of like an extensive process, and with a lot of different pieces that and a lot can go wrong along the way. And usually consultants have figured out certain ways of going about different changes. So they might not need to change here. They might change the control tables and start here. So we were thinking to ourselves, wouldn't it be nice if I just wanted to change a few parcels? If my county or city wanted to change a small corner of the town, to be able to go from here to here without having to go through all of this. And that is the question we wanted to answer with region. And that's where region came from and why we developed it. I'm going to talk a bit about it next, but I'm going to pause here to take some questions. Are there any questions on this? Yes.
Might be more of a question for region, but when you do get to the end of the process there, how does the process differ from what you guys were doing before when you create future forecasts? Say we have a general plan and all of a sudden they're going to add 10,000 new households that you never accounted for before. And how's it going to find the employment for those given there's now an imbalance, or vice versa? You're at the edge of the model and you're adding 5,000 employees that have no matching households. Your process before was, I'll call it manual. Is there anything in this that's a bit more automated, or is that part of region?
I'm going to talk about how region deals with that briefly, and what it can and what it can't do. It can do some of these things, but not everything. And we can talk a bit more. We're going to go through that. I appreciate you highlighting that. Yes. Any questions?
I think we can keep moving.
Okay. Yeah. We even use different template for this one. So region, our regeneration tool for regional land use and population files. So what is region? It is a land use updating tool. It regenerates model run files based on land use updates that you make directly on a map in GIS. It does not require extensive modeling experience to run it. And it's aimed at making land use updates a lot less costly and a lot quicker. So this is where it falls within our general, this all general update. You still need to know how to do your land use updates. So if you have new households, new employment going in, you still need to know where those are going to go in. But it helps you go to usable model run files much more quickly. Now, how does it perform versus the population sim and our full process? First, it's a lot faster to do. Scale in terms of like this could take you a few days to get done, a couple days. This you'd need like a week to do a good update. This is very surgical, where if you're doing changes to, let's say, 100 parcels, only those 100 parcels get affected. Whereas if you want to run population sim, you get region-wide effects. And when your changes are very small, you don't want randomness of running a synthesizer to overshadow the changes that you made. It's much better to keep everything else the same. But it has a much simpler process. You follow a user guide, and it's going to be pretty easy to use, hopefully. And it's much better for local changes. So general plan updates that have a limited number of changes, or if you want to test certain scenarios. But population sim, if you're doing a major update, a lot of units, a lot of employment, it's still the way to go. Well, I think employment will be okay either way, but if you're changing dwelling units up to a certain amount, population sim becomes better. But if it's still limited changes, region performs better. And this one only updates the model RAM files, whereas population sim updates everything in the middle and helps you kind of track what's happening along the way. And the region has limited customization in terms of what you can and what you can't do. We're going to talk a bit more about that. Whereas population sim, you can change the variables. You can do a lot more with population sim in terms of customization. Not everybody wants to do that, but it's good to have. So how does it work? So first of all, you start with the parcels you want to modify. We're going to send you a file package that has a GIS file that you can open up with a bunch of parcels, and you identify the parcels you want to change. You say, let's say I have this region and I want to add this many households on it. I want to add 200 households instead of 2. There's no employment in this area. I want to add 300 employees. it requires you to know where exactly these households are going to go. So you need to make the decision on which parcels are going to have these households, and where the employment is going to go and the types of employment. So you need to identify, okay, these are office buildings, this is a medical facility, and apply those changes on the parcel level. And once you do that, you need to set up the region. It requires downloading R Studio and 4 or 5 libraries. And then you modify the toggles that we have for region. So one of the toggles is the SACSIM version, whether you're working with SACSIM 19 or SACSIM 23. It also has a toggle for year. Is it 2020? Is it 35? Is it 50, 40, depending on the SACSIM version? So it only works with our full year versions for now. And the household total control. So let's say you added 100 dwelling units, but you know that your general plan update requires 90 extra households. So you can add those 90 extra households here to the total control and make sure that you hit that exact number. Also, if you a lot of times, the general plan update says, oh, we want to add for those 90 households 300 people. You don't have to do any guessing. You could just add that 300 number here to the existing number, and the tool will match that number for you. In terms of the households that get generated, we'll make sure that their size, as long as it's reasonable, you can't add like 1 million people that belong to 3 households. But if it is reasonable, the tool will be able to adjust the households for that. And also a household size control. Let's say you don't really know what your population size is going to be, but you know that you want to match the regional total. You don't want to mess with anything in terms of regional averages. You can apply that total. We found this toggle useful for us because certain types of developments are larger versus some of them are smaller. You can keep your regional household size control. Okay. So to run the tool, when you start running the tool, you basically you do all these things, and I'm missing one. It's fine. It's basically hit run. That was the missing line. It's hit run, and it should run. And what it does is that parcels with updates to dwelling units, they get populated with households and persons based on community type, density, and the county we're working with. So similarly to what we did for our projections, we applied a similar methodology in terms of it's sampling people. So you're building a mixed-use development. You're going to get a household that's going to have similar characteristics to a household that usually lives in a mixed-use development. So we're able to add these households to only the parcels that got affected. And then we also apply the new employment. If you change the employment, we add that to the parcel file. And we mentioned buffering is super important. We're not getting around it, but we integrated the buffering process into the script. You just have to hit run on the buffering step, and that will give you the new parcel file that is already buffered, including all the updates. And then you get ready to use model run files. And your output is going to look something like this, going through the different steps that it's doing. And in terms of time, most of the time is deciding where your developments are going to go, what's the type of development going in, and where. This tool takes around 15 minutes to do all the work, but it takes a couple hours to run buffering, depends on your computer. So the first, all the changes to population and getting the actual population tables takes 15 minutes, but then a couple hours to get the parcel table that is rebuffered, which is really a great improvement in terms of how quickly we can get these files done without any mistakes or without any errors. And just about deciding where the new development is going to go and applying it. So while testing this tool, we had a test case where we added development in Roseville. So, before I go to the test case, do we have any questions on like the operations of it? Yes.
So in the example, you even started with the 200 households and 300 employees, and you're doing this as kind of a scenario where you're making a modification.
Yeah.
You just created an imbalance where the 200 households might create 240 jobs, but not 300.
Yeah.
So does the tool kick out any kind of error message that you've now created an imbalance that needs to be addressed manually through either IXXI adjustments? Is there anything like that that's going on as a check?
The only imbalance it might flag for you is if your household and population controls don't match. If you add a lot of employment to an area without any population, or a lot of population without any employment, it does not. That will be reflected in your model run results. It just gives you the updated model run files. It might give you a population and run files that are going to have bad results, but it'll do that for you. Yeah, a good question.
I have two other here.
Yes, sure.
Yes. So online, can you split or add parcels using regen again for large greenfield specific plans? Also, can you split TAZs using regen?
The short answer is no.
Okay.
You have to depend on the current parcel structure, but the current parcel structure is split based on our projections as well. So if something is going to get an area is going to get developed by 2050, and let's say you want to bring that development earlier on, that parcel is already split. It's not, yeah, but if there's a large parcel that is greenfield, you can't change its geography up until now. Yeah.
Great. And then additionally, does the parcel fabric contain all possible parcels or only parcels where there already is land use land use,
Yep.
OPR, SACOG, or SACOG anticipated land use?
Yeah, I think that's a great question. This tool works for existing developments and for greenfields as well. Even the areas that have nothing in them, not nothing, but no dwelling units and no employment on them, it has the capability. You have the capability to apply development to greenfield areas.
Great, thank you.
Yeah, that's great. Yeah, thank you for that. So moving on to the test case, we have here we did a test case where we decreased the number of dwelling units in West Roseville for year, I think, 2035. And we added some dwelling units in south of Elk Grove, between Elk Grove and Galt. And the total number of dwelling units in the region went down in this case. We removed more than we added. And we added the employment over here. Now, generally, I would advise if you're using region, to stick to one area, and that's where you're doing your update. But this was kind of like testing the limits and trying to understand what happens. So when we reduce dwelling units, what do you expect to happen in terms of volume, traffic volumes? Less travel, right? Added the dwelling units in this area without any employment. Where do you think they're gonna go? They're gonna probably use the collectors up here and then travel up 99 or go up 5, depending how fast they can get there. And here in this area, you added employment, but no households. People are gonna drive there. And we ran that through our model. And here red is an increase in travel. And a green is a decrease in travel. Generally, you see like an overall green because of a reduction in the total households in the region. A large green area over here where we reduced the number of households. The households that got added here are joining in on this collector and on this collector and driving up 99, which is kind of like one of the major roads with the red on it. And a lot more traffic is heading down to the area between Davis and Woodland because we added employment there. And we've done multiple tests on this, and some of them are very localized in terms of their effects. Some of them have wider regional effects. And possibly use cases for this tool is using it for general plan updates. And we actually used it and developed this tool, helping one of our regional jurisdictions with their general plan update and their consultants. But I would think about how large the changes are. Are you adding a lot of units, or are you adding a limited number? Are you changing where they are? That kind of thing. You can use it for an SB 743, where if, let's say I want to add 100 units to my jurisdiction, what impact will that have? And scenario testing, what if? And I want to note that this is not a replacement for the main modeling process. So if you're doing very large scale changes, we still recommend using the overall general population census and allocation process. That's still very valuable. It is meant to be used for local scale changes. it still requires an expert to determine and allocate where the growth is going to go, where the employment is going to go, and what kind of employment. So you can put very bad inputs in there, and yeah, like garbage in, garbage out. You're still going to get bad travel, a bad case of behavior when you do that. And it does not run the model, and it does not analyze the result. It just gets you to the model run files a lot more quickly. And I'm going to go through like an example of Marysville. Any questions that you want to ask? Yes.
Well, when you say it can be used for something like general plan or
Yes.
743, I think there's a couple key differences to acknowledge, and maybe put this in the notes,
Mhm.
is that a lot of the smaller land use changes, they change land supply. So there's new area that residential growth could go into. It doesn't change your control total based on the future 2050 growth forecast. It just changes the allocation of where that growth may go. So if someone were to run this where, as you said, just added the units, now you've disconnected from the growth control and created a total that would be higher than that 2050 scenario. So we try to avoid that in practice whenever we can, because the idea is we want to capture the effect of the project. The fact is we're entitling some new land supply will increase for residential. It may go there, it may not go there. So maintaining control totals seems to be like one important aspect if you're doing something like general plan or 743. And it sounds like you're completely capable of doing that, because you can do the decrease at the same time you're doing an increase.
Yes.
So that seems like a really nice feature, but might want to emphasize that if this is intended for those types of analysis.
Yes, I totally agree. It can be used for adding, but it's also great for shifting growth. And a lot of these general plans, they want to shift the growth or where employment is or where the dwelling units are, because they do have better knowledge of the local areas. Even they can even update enrollment numbers, because they have better numbers on that. Employment splits. They sometimes, the local jurisdictions, or most times, they have better information on that. Yes.
Raheem, do you mind if I add just a
Yes,
little bit
sure.
to that? So we had this exact discussion, and once you take a look at the tool, and we actually started with that control, meaning you must hit your control totals, and it errors out if you don't.
Yeah, so now it's a toggle.
But we even came across, right, like if a general plan wants to use our modeling, we have SCS in there, SCS control totals. They have general plan control totals. And so we essentially gave the option to the user to, do you want to maintain your control totals? If so, what are they? Or do you want to over exceed it? So we're giving the user the more flexibility, but like you said, for an SB 743 analysis, it's important for the user to be understanding what they're analyzing. So we allowed more flexibility, but then with that comes greater risk.
Yes. Yeah.
And responsibility. Thank you.
Yeah, thanks for that, Kyle. Yeah. So we actually developed this when we got a data request from the consulting team working with the city of Marysville on their general plan update. They were asking us how to go about this, and we were starting to think about how to apply this tool, and we kind of worked through getting it done for them. We actually ran it for them. We hadn't released it yet, but we gave them a GIS file and asked them, tell us where things are going. What are the changes you have? So we gave them this GIS file and the parcel level file, and this is where the dwelling unit changes are. And some of it was they were shifting where the dwelling units are going to go in 2050, and some of it was they were increasing compared to the draft number that we gave them. And they also gave us employment